Okay, welcome to the 2025 December 15th Algebra 1 Review, session number 1. I'm Mr. Mack, your host. I'm here with at least 1,000 other students ready to learn Algebra 1 for the first time in their lives. They've had all semester to learn this stuff. They decided not to. They said, nah, I'm going to do my own way, and their own way is to learn it at the absolute last second. The final will consist of questions from previous quizzes. It'll be less than what's on the quiz, but it's not going to be as simple as 3 questions from every chapter or something like that. Whoever was spreading that rumor, moron, idiot. But yeah, it's going to be any of this stuff. If it was on the test, it's more likely to be on the final, but I can grab stuff from previous quizzes that wasn't on test to put on there. The general concept of what I'm trying to do here is I'm trying to see, do you know your crap? If you know it, you're going to be fine. Do you have to get every question right in a box in order to maintain your grade? No. Do you need every question right in a box in order to improve your grade? It depends, but mostly yes. If you make small mistakes, I'm more forgiving on the final, because unless I'm testing do you know what 5 plus 2 is, and I'm probably not, except maybe quiz 1. If you tell me the answer is 10, it's not that you didn't understand how to do substitution, it's that you're not capable of doing calculation, which is not what I'm testing. So you can make small mistakes and get away with it more. I'm pretty lenient on this final stuff. If it's clear you do not know your stuff, I will drop your grade down. That doesn't happen often, but it does happen to a lot of kids that try to BS their way to having a higher grade during the semester, so mommy and daddy don't get mad at them, but don't actually understand the stuff. They just kind of learned a quick trick and then forgot it 5 seconds later. So if that's you, I would definitely study this stuff. There are no secrets on this final. It'll be the same thing as always. It'll just be the same questions with numbers changed. I don't know what you want from me. All right, speaking of what you want from me. Page 1 of quiz 1 on the basics. Does anybody want to see any of these? Please, speak now or forever hold your peace. Cool, I'm going to pick some then. So, 132b, negative 999 and positive 1001 has a difference of 2. This is a good question, because this is really hard if you don't see it. 222 minus 225 comes out to negative 3. So we had a negative 3 and a positive 2. It doesn't matter what order you put them in. You can do 2 minus 3, or you can do negative 3 plus 2. The 3 is negative, the 2 is positive. No matter what, it's going to come out to negative 1. If you're not doing it like this, you're doing it wrong. And what I mean by that is, like, you can get the answer lots of different ways, but, like, girl, are you really doing 222 minus 999 in your head and then subtracting 225? If you are, get some help. You know who you are. All right, now I want to draw your attention to some down here real quick, not because the stuff is hard, but because nobody reads. Evaluate each of the following expressions inside the parentheses, then use distributive property to expand the product. For example, these two right here. So I have 2 times the quantity of 8 minus 3. First time I did inside the parentheses. 8 minus 3 is 5. 2 times 5 is 10. But then I went back and redid it. I did 2 times 8 minus quantity of 8 minus 3, and I wrote it as 2 times 8 and 2 times negative 3. Are you seeing this? Okay, fine. You don't need to tell me that. Do you see that we're distributing here? 2 times 8 minus 2 times 3? Hey, look, they got the same answer twice. They should. It's the same problem. I need to be able to see that you can do this both ways. So, for instance, if we do this first one here, I want to see 3 times 7, which is 21. And yeah, when we get 3 times 2 plus 3 times 5, you better also get 21. It's true. We get 6 plus 15, which is indeed 21. Down here, people freak out when you multiply from behind, but it's no big deal. Parentheses first. 6 minus 12 is negative 6. Yeah, that matters. Times negative 2, well, if we negate it once, it's going to be negative. If we negate it twice, it's going to be positive. So our answer is positive. What's 2 times 6? 12. Then we have 6 times negative 2 minus 12 times negative 2. That's when we're distributing that negative 2 to both of these. Notice the 12 is negative. Yes, that matters. This becomes negative 12. This becomes positive 24. And when we put them together, we get positive 12, the same answer we got earlier. I sure hope it does. Sorry, the soundboard isn't working still. I would have fixed it today, but I was sick. Speaking of sound, I cannot hear out of my left ear, so I'm extra deaf today. Any questions on the first page? None? Okay. Turn the page. Page dos. Tell me what you want, what you really, really want. Do not be afraid to ask questions. Okay? A lot of you guys are like, I don't know what I'm doing on quiz 1, and it's been forever. So please ask dumb questions today. This is your last chance to ask dumb questions. Dumb questions are the best questions because it's something this small holding you back from something this big. So please let me fix something this small. Yes? Absolutely. Anybody want to see 1, 4, 3? I'm going to go over the directions. Factor a 4. It might say a 3. It might say something else. Factoring is not division. Here's the example. Do you see we have 24 plus 40? What common factor do they share? 4. They said take out a 4. What you're left with is 4 times 6 plus 10. Yes, we can factor that more. We know that now, but it said take out a 4. 96 and 44. If we take a 4 out of those, we definitely know this is 11, right? Definitely 11. Okay, cool. How many times does 4 go into 96? Better question. How many times does 4 go into 100? 25 times. So this is 1 less 4 than 100, isn't it? So instead of 25 4s, we're going to get 24 4s. This also makes sense because 4 times 20 is 80, and 4 times 4 is 16. Hey, 80 and 16 makes 96, right? 80 and 16 makes 96. If there's 3 terms, never fear. This is no big deal. Take out 4, we get 22. We get positive 9, and we definitely get a negative something here. How many times does 4 go to an 120? 30 times. So how many times does it go into 124? 31. Very good. Do I want you to simplify this? No, please, God, no, stop. Don't do that. Just factor it. That's all I want. The idea is that if you can do it with numbers, you can do it with variables. That's why this is quiz 1. Down here, we're talking about Mercer. He subtracted 7 from the equation. He took 7 equals 10 minus 3, and he subtracted all of this from all of this. So if you look, there's the 24, and he's subtracting what? Oh, he's subtracting 10 minus... What is going on here? Is this one just goofed up? This should be a 7. I don't know why that's a 4. That's funny. Then he's taking all this stuff over here, and he's subtracting 10 minus 3. So assuming that was a 7, that wasn't the mistake he was supposed to make. What is the mistake that he made? Because if you look, taking away 7 from this side and taking away 7 from this side should work, right? 10 minus 3 is 7. It's just a weird way to write 7, but you took 7 from both sides. So why does this end up not coming out correctly? Took away 7 here, took away 10 minus 3 here. Why didn't it work? Yeah. This right here represents negative 13, doesn't it? What he should have done is this. Made it one term with parentheses. Because now you're subtracting whatever 10 minus 3 is, right? Now you are subtracting 7. Parentheses matter. He could have also done this. He could have said, I'm going to add 10 and minus 3. Sorry, let me say it again. Minus 10 and add 3. That would have also been the same thing as subtracting 7. This is the same thing as distributing that negative, right? Distribute the negative to the 10, distribute it to the negative 3. Same concept. Cool. All right, turning the page. 161. That's correct. That is correct. Okay. Anybody want to see any of these? 2 to the 4th, 0 to the 5th, 69 to the 0th. Pop quiz, what's 69 to the 0th? Thank you. And it is this way because, and you need to show me this, squaring means this, to the 1st. Well, as we go up, we're increasing this by timesing another 69, right? That means as we go down, if we're timesing on the way up, what must we be doing on the way down? We're dividing. We're going down. Very good. We're dividing. Yes. And so if we divide, 69 divided by 69 is 1, and we get 1 times 69, which is 69. Nice. If we continue this pattern to get to 69 to the 0th, we will not get 0 because is 69 divided by 69 0? Hello? What's 69 divided by 69? 1, and that's why. I need to see why. It says show your reasoning. Okay? If my paper is ever not on the screen, please let me know. All right. Anybody need to say anything on page 4? I'm guessing the answer is yes. Okay, what about 1/7s? Come on, be honest, guys. Okay, 1/7s. All right, we're going to do them all. 36, and this is going to be good because the rest of your class is going to need to see them too. 36 to the half power is asking what times itself gets you 36. In other words, it is asking for the multiplicative half, right? So there's two things multiplying to make 36. I want half of it. What number has it got to be? It's got to be 6. It's not asking for 18. If I wanted you to divide by 2 or times by a half, I would have written times by a half. I would have written divide by 2. So the multiplicative half of 36 is 6. You knew that one off the top of your head. Now, this one's actually really easy. We love zeros. What's the multiplicative half of 1 with 1, 2, 3, 4 zeros on it? Well, it's got to be a number with 2 zeros, right? Because that'll get you 4 zeros. I know. It turns out, whenever anybody comes to see me for help, the number one thing they say is, oh, my God, it's that easy? Yes. It's always been that easy. We had like 3 weeks to learn this, and you guys are like, ugh. I know. So it's got to be 100 and 100, right? So half of it's going to be a single one of those 100s. It's that simple. Oh, my God, what if I had 10 zeros? What if that had 10 zeros? Then we'd have 5 zeros. Wow. 100,000. Wow. Wow. What is 0 to the half power? Well, that's asking for this. What do you times by itself? Thank you. It's 0. Yeah, it's 0. I know. Mind-blowing stuff. All right, 196 rooted. Did you know that means the same thing as this because it's a square root? These mean the same thing. So you might not know what 196 to the half power is off the top of your head. Well, I have good news for you. There's a way to figure this out. What we're going to do is we're going to break it down using factoring, meaning we're going to turn it into something times something, and we're going to see if we can take the half power of that. So here's what I mean by this. Please, for the love of God, Eli Weilacher, I am talking to you. Please organize your work like this. You guys always forget the root because you're too busy drawing trees, which is like super cute and stuff, but you always forget the root. And this is literally the same thing as drawing trees, except it doesn't forget the root. Wow. Okay, so turn this into something times something. Do you know what number goes into 196? 2 definitely does. 13 does not. 13 goes into 169. So 2 definitely does. 7 certainly does. 4 certainly does. 98 is going to get you 180 plus 16, which is that. So 98 and 2, yeah. If you can do 2 and 98, that's cool. But if you got 4, 4 is even better. Why do I prefer 4 over 2? 1, it's bigger. And 2, I know the root of 4. What is the root of 4? It's 2. So I'm going to show this 2 ways. Here's, when in doubt, it's even, right? So I guess I can write it as 2 times something. Do I know the root of 2? No. Do I know the root of 98? No. So I keep going. 2 times 2. Hey, that's 4. 2 times what gets you 98? How about 49? Check this out, right? I know the root of this. What's the root of 2 times 2? Okay, this is 4. What's the root of 4? Do you see how the multiplicative half is 2? Right? The multiplicative half is 2. And then the multiplicative half here is what? 7, and they were being multiplied, right? Notice I've gotten everything out of the root, so I literally just get 14. Turns out 14 times 14 is 196. Isn't that kind of kooky? 13 times 13 is 169. 14 times 14 is 196. Another way to do this that is faster. 4 times, what was I going to say here? 4 times, oh yeah, this is 4 away from 200, right? 4 times 50 is 200. So 4 times 49 is 196. Oh, hey, look. I know this is 2 when you root it. I know this is 7 when you root it. Looks like it's going to be 14, right? Nope, I can't do that right now. Sorry, this is the risk you took. All right, this right here. Let's break it down into numbers we know the roots of. Can anybody see a number that we could break it down into that we know the root of? Mars. 9 is really good, except you don't know the root of 9. Well, you do know the root of 9. It's 3. What's better is bigger numbers. What about 81 times 100? I know the roots of both of those. At some point, guys, I do need to require you to be able to see things. It's kind of like an optical illusion. Once you see it, you can't unsee it. That's just math, baby. It's not a matter of just doing steps all the time. So here, we know the root of 81. It is 9, and we know the root of 100. It is 10. So this is just 90. Yeah, 90 times 90 is 8100. That's pretty slick, huh? Pretty slick. Yeah, I'm slick with it. All right, now we have another problem. These are not half powers anymore. These are 1/3 powers. So this is asking this question. What times itself 3 times gets you 216? What is the multiplicative third of 216. We want that number. Now, here's the good news. This is not a very big number. And if you times something by itself 3 times, it's going to get big really fast. So think about it. If it was 10 times 10 is already 100, times 10 again is 1,000. So this is definitely less than 10, right? It's got to be less than 10. My guess would be a 6, because when you multiply something by 6, it always ends in a 6, right? 6, 36. You're going to get 216, right, which is the next one, right, 216. If you don't know that, that's okay, because you can do this. It is important to have the 3 here. If you don't have the 3 here, it's a square root. That's a different question. That's not this. So let's break it down into numbers we know. Hey, look, it's 2 times something. 2 times what? 108. 108 doubled gets you 216. Are you seeing that? 216. I don't know the cube root of 108 off the top of my head, so I'll do another 2 because it's even. 2 times what gets you 108? 54. Very good. 100 plus 8. 100 plus 8. I don't know the roots, cube roots of those. Be careful. I'm not asking for a square root, right? I need 3 2's before I can cube root it, right? I need 3 2's. I only have 2. So I'm going to do it again. And look, now I've got my 3 2's, which is nice. And this is still the same number. 2 times 2 times 2 times 27 is still 216. I didn't change anything. I'm just rewriting how it looks. And I know the cube root of these numbers. What is the cube root of 2 times 2 times 2? What's the cube root of 8? 2. Do you see how it shows you the cube root? Right? That's really nice. If you don't see this, you can write this out. This is 3 times 3 times 3, isn't it? 9 times 3. So what's the cube root? 3. So it turns out the cube root of this, like I said earlier, is 6. That was the answer to this question. That's the answer to this. It's 6. Will all roots go away nicely like that? No. No, they won't. Sometimes you'll have stuff left over. All right, this one's asking for the 4th root. What do 4th roots mean? Ding, 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 ding. We want the multiplicative quarter, right? A quarter of 1296. Does anybody see that this is 4 away from 1300? Yeah, so 4 definitely goes into it, right? Here, let's do it. Think about how many times 4 goes into 100. How many times does 4 go into 100? 25 times. So that's 100, right? How many times will it go into 200? 4 times 50 is 200. Cool? How many times will 4 go into 400? 100 times. So this is 400 times 3, essentially, right? You guys seen that 1200, right? So we have 400, 400, and 400. That's 100, 100, and 100. That's 300. 4 times 300, just so you guys are following me. 4 times 300 gets me to 1200, right? See how 96 is almost 100? How many times does 4 go into 100? So how many times is going to 96? 24. So check it out. I know 300 4s and 24 4s would get me 1296, right? So how many 4s is that in total? 324. Pretty slick, huh? Now, if you didn't know that, you could just do 2, right? 2 times 648, right? 648. And you can just keep going. But 4 is better to take out because it's bigger. But if you wanted to, 2 times 6, 98. And then you can go from there, right? You could totally do that. What's nice about 4, and this is a 4th root, is that it gets me there faster. So 324. Does 4 go into 324? It goes into 24 8 times, right? How many times does it go into 300? Better question. How many times does 4 go into 100? 25 times. So it goes into 250 times. So it goes into 300. 75 times. So we have 75 plus 8. It's going to be 83. And that makes sense. 4 times 80 is 320, right? And 4 times 3 is going to get us 12. Yep, I think I wanted 81. I think I just added that incorrectly. I'll do it again. 4 times 80 is 320. 4 times 1 is 4. Yeah, there we go. We'll pretend I made that mistake on purpose. Yeah, 4 times 80 is 320, right? And 4 times 1 is 4. Yeah, I just added those 2 numbers incorrectly. Wah? Oh, yeah, thank you. I'm going to make a lot of mistakes today, guys. I can't hear out of one of my ears. I can't really talk super well. I'm, like, heavily medicated so I could be here. So I'm going to make mistakes. Because it's the right thing to do. That's why. Are you guys seeing this? All right, now check this out. This is 2 times 2 times 2 times 2 times 3 times 3 times 3 times 3. I know the fourth root of this. What is the fourth root of this? 2. Multiplicative quarter, right? A quarter of this would be one of the 2's, right? What's a quarter of this? One of the 3's, right? Hey, look. This one's also 6. Now, I want to talk about what happens, and maybe we'll talk about it in the intermediate. Sometimes there's, like, numbers left over. Imagine there was, like, a 5 on the end here. Just one 5. I can't do anything with that, right? If there's just one 5 on the end. So I'd have 6 times the fourth root of 5, right? I'd have the fourth root of 5 left over with a 6. Cool. All right, turning the page. We're on intermediate. Anybody, page 5. Are we sure? Yeah. Okay, because everybody likes to subtract these and get 1 and then take it to the 5th or something. Don't do that. This is 9 minus 8, which is 1. Another thing that everybody does here is this. Once they get here, 9 minus 8 is 1. They always do 6 minus 5 next. Tell me if you were doing that in your head. Don't tell me. It's embarrassing. Are you going to do 6 minus 5 next? No. Why not? Because this is all one term, right? Mm-hmm. Yeah. Now, it turns out in this case you'll get away with it. 6 minus 5 is 1. But if that was a 2, a 3, a 4, a 5, a 6, 7, 8, anything other than a 1 here, it would not have worked. This is 5 ones, that's 6 ones, so technically you can subtract them right now. But you need to do this part first, okay? Keep like terms together, or keep terms together, and then combine like terms. All right, turning the page. Anybody need to see any of these on page 6? Page 6. All right, this one right here. Yeah, that's a good one. We're definitely going to talk about both of these. Does anybody need to see 1, 2, 1, any of these? Please, for the love of God, be honest. You guys know this is 8 minus 12, right? Negative 4 squared is positive 16, yes? This right here is 12 squared, which is 144. You have to do 8 minus 144. It's going to be a very big negative number, negative 138. This right here is 8 minus 4, which you cannot do first. Does anybody know why? No, it's because, I know what you mean. Because this is one term, right? And these aren't like terms. So we have 8 minus whatever 4 times 9 is. Again, you need to do this first because it's all one term. This is a separate term. Anything separated by a plus or a minus is a separate term. We get 8 minus 36. Oh, now they're like terms, right? 8 ones, 36 ones. We can do that. 8 ones and 4 nines. Can't combine those. But now we can combine them. 8 ones and 36 ones. We subtract them, we get negative 28, right? Cool. Down here. Do you see how 83 is negative? See how 49 is positive? Anything that changes that changes the problem. So look at this. See how 83 is negative? See how 49 is positive? This is the exact same thing. Do you see how 83 is now positive? Why? That's a different answer. See how 49 is now negative and 83 is now positive? Impossible. That's a different thing. See how they're both negative and they weren't before? Impossible. How could it be the same, right? We're not moving things across an equal sign or anything. We're just changing the order. That's it. Now that you understand that, what's the answer for 133? No, 133, blood. Do not, I swear to God, do not actually figure out what this equals and see which one equals the same thing. If you're doing that, you're missing the point and you will never get this one right. Because you can't actually put these together, right? Here, a lot of you guys like to add these together, figure out the answer, and then check it with all these. Takes forever. 2, when you get here, can you add these together? No, you're stuck. You got to know the concept. What's the right answer for 133, Mars? It's got to be what? D is in dog, yeah. See how B is positive and A is negative? I mean, it didn't change anything, so it'll be the same, right? You should know that. Oh, no. We have to do 403 times 19, then divide it by 35, then times it by 35, and then divide it by 403. No, you don't. Yeah, because why? It's, how many terms do you see? One term, no pluses or minuses. So we can do it in any order we want. We can divide first or times first. Blood, if it really makes you feel better, you can put the 403, divide by 403 underneath this if you want, right? It doesn't matter what order you times or divide in. It's all one term. I'm not going to do that because I want to do this quicker. 403, it says divide by 403. Doesn't matter when we do it. It's all one term. What's 403 divided by itself? It's important. When you say cancel, it gets you in trouble. Sometimes things don't cancel to ones. Sometimes they cancel to twos or threes or fours or fives or zeros, and it makes a huge difference. So think about what's going on. Anything divided by itself is 1. Same logic here. 35 divided by 35 is 1. So all we're left with is 1 times 19 divided by 1 times 1 divided by 1. So what's this going to equal? 19. It's that easy? Yeah, it is. Did you know we're on the intermediates? You know the stuff you need to get an A? Wow. This is not hard. You guys were just dumb. And by dumb, I mean not that you didn't know math, although that was also true, but because you guys are like, I don't need to pay attention. School is easy. I should be able to get an A without having to think. And that just doesn't work in here. But you know that now, which is why you guys are better at this. All right. Is it true that 5 minus 3 equals 3 minus 5? No, because look, 5 was positive and now it's negative. They're not the same thing. Is it ever true that you can just change the order of these numbers? 5 switches to the second spot, 3 switches to the first spot, and we keep it as minus. Is there any set of numbers that we can actually flip and it'll still work? What set of numbers? If they're the same number, yeah. What if it was 5 and 5 to start with, right? If I flip those, so this is the first number, this is the second number, right? If I flip those, where now it's the first number here and second number there, it's still the same thing. It's a silly question, but it's true. So yes, this is an example. 0 minus 0 would be invertible like that, right? All right. Gracie expanded the product of -2 times 5 minus -3. Okay, guys, if we're expanding, it means distribution, right? -2 times 5 is what she should do. Okay. Does she do that? Yes, awesome. Then she's supposed to do -2 times -3. I see -2 times -3. However, what's the problem? She has too many minus signs, right? -2 times -3, you should add it to that. Or you do it like I do, where you're like, -2 is just going to leave a minus sign out here, right? Do you see if we have a minus sign here, this is going to be a +2 times -3? That's definitely not what we wanted, right? So she has too many minus signs. So she either needs to write it like this. This will happen to you, by the way. Whoops. -2 times -3. Or she needs to write it as -2 times 5 minus 2 times -3. So either keep the minus sign with the -2. Here, let's do it this way. Let's do it that way. Either keep the minus sign with the -2, like I did here, right? And then we're just going to add them. Or she can keep the 2 times -3 and then just put the minus sign out there. Those are your options. Either way, we're adding a negative version of 2. We're minusing 2, right? Yeah. Okay, down here. Oh, no. How many terms do you see? 1 term. So we can do it in any order we want. What is 19 divided by 19? So this becomes 1 over 1. What's 5 divided by 5? 1 over 1. I do want to give you another example here because this is just 27. I want to give you another example and prove to you why you can't just say cancel. You have to think about what's actually going on here. So here's my other example. 10 times 27 times 19 over 19 times 5. If you think things just cancel, you're going to get the wrong answer here. 19 divided by 19 is still 1, right? But what is 10 divided by 5? It doesn't just go away. What happens? We get 2 over 1, right? That's super important. Okay? And now we're going to get 54. I want to give you another example. Let's do this. We'll do 6 times 27 times 19. And then we'll do 19 times 9. 19's divided out to 1 still, right? Because it's all one term. What is 6 divided by 9? Well, don't they have a common factor of 3? This is 3 times 2, and this is 3 times 3. So the 3's divide out to 1's. But we're left with 2 times 3, aren't we? So what happens? Well, we get 1 times 2 times 27 times 1. That's 54. And in the bottom, we get 1 times 1 times 3, right? So we get this. If you wanted to, you could even do 27 divided by 3 first, because this simplifies. What is 27 divided by 3? 9. So now that becomes a 1, and look, we get our answer, which is 9. That's what this would simplify to anyway. You could have also done 27 divided by 9 here instead of 6 divided by 9. That would have been quicker, right? But there's lots of ways to do this. You need to think about what's going on. It's division. There's no reason to say cancel. It's not any faster than division. Actually think about what's going on. And that's just one example of why you need to actually think about what's going on. Speaking about what's going on, next page. Yes, no, maybe so. Do you know the difference between A and B? This is true. Because this, it depends on how many negatives there are. This means times negative 10 by, or sorry, take negative 10 times itself 6 times. Is this going to come out positive or negative? Yeah, make it negative, make it positive, make it negative, make it positive, make it negative, make it positive. This is going to be positive 10 with 1, 2, 3, 4, 5, 6 zeros. I always do that. Commas are hard. This means I want you to take 10 to the 6th, which means this. But I want the negative version of that. Does that make sense? We need to have a way to say I want the negative version of this. So that's the way to do it. I want the negative version of 10 to the 6th. If I write this, doesn't it mean I want the negative version of 2? Right? Doesn't that mean I want the negative version of 2? This means I want the negative version of 10 to the 6th. 10 to the 6th is this. There we go. And now I want the negative version. So this will always come out negative because it says I want the negative version. This right here, it depends on how many negatives there are, right? All right, what about C and D? Yes or no? Yeah, I'm tired of you guys saying this is negative 12. I'm tired of you guys saying this is negative 81. No, negative exponents mean repeated division. Let's try this. Position 1. I think it's already there. It is. All right, let's talk about how this makes sense, okay? You know that positive exponents mean repeated multiplication, right? Am I visible? Is that coming up? Okay, cool. So that means this means 3 times 3, and this means 3 alone. And that is because as we go up, we're timesing by a 3. We talked about this earlier, right? Which means as we're going down, we are what? Dividing by 3. Cool. So negative exponents are the opposite of positive exponents. Positive exponents are repeated multiplication, right? So what's the opposite of repeated multiplication? Repeated division. It makes sense. Negative exponents don't make things negative. If you continue dividing from here, you don't get a negative number. What's 1 divided by 3? 1/3, which you might notice is the reciprocal of this thing, right? 3 to the first reciprocated. 3 to the negative second means divide by 3 twice. Are you seeing that? Dividing by 3 twice? So that's really just 1/9, which you might realize is the reciprocal of this, right? 3 to the negative third means divide by 3 times. Now, why do we have a 1 on the top? Because anything to the 0th is 1. That's where we start from, right? That's where we start from. So this means the same thing as 1 over 27, which you might notice is the same thing as this reciprocated. So what's 3 to the negative fourth? It means divide by 3 4 times. Am I in the way of all this? Can the camera actually see this? Yeah, mostly. Okay, cool. So that means 1 over 81. I'm not used to standing out of the way of the camera. Cool? That's what we're doing here. Notice that's the same thing as 3 to the fourth. 9 times 9. It's just reciprocated. That's it. If it was negative to start with, that can change things, though. So, for instance, if I had negative 3 squared, that means this. Is that going to come out positive or negative? Positive or negative? Positive 9. So if I have negative 3 cubed, it would come out negative 27, right? I times on another negative 3 here and make it negative. So if I did negative 3 to the negative second power, that would be 1 over 9. But is negative 3 to the negative third going to be 1 over positive 27? No, it's going to be negative, right? Yeah. So you got to watch out for that. But negative exponents don't make things negative. This was already negative, and when it's an even number of negatives, it comes out positive, right? And when it's an odd number of negatives, it will come out negative. Okay, cool. Do we need to see part D? I'm guessing yes. Yes, let's do it. Somebody online will need it, if not you guys. Okay, so this means this. It means square it. Oh, that's right. Thank you. I don't have my soundboard set up, so I can't switch things manually. Oh, that's going to be really fun. That's really fun. Oh, boy. All right, well, anyway, what this means, a way of interpreting this is this. Check this out. What if we square it first and then negate it afterwards, negative power after? See how this is the same thing as that? Right? This is the same thing as that, right? Yeah. So let's square it first. What's 1/3? Negative 1/3 times itself. I know what you mean. It's going to come out positive. Yeah, that's what you meant. That's what you meant. Negative 1 times negative 1 is 1. And 3 times 3 is 9, right? So if we do that and then take that to the negative first, we'll get our answer. This is going to be 9. It says take 1 and divide it by a ninth, right? Take 1 and divide it by a ninth. That's what this means, right? Repeated division. Repeated division is what that means. We're going to divide by this number once. We start with 1, and we divide it by this. How many times does a ninth fit into 1? 9 times. Now, there's an easier way to think about this. Remember earlier I talked about on the board, I'm not going to flip it over there because it'll take forever to flip back. Remember on the board earlier I talked about how like they're reciprocals? So like 3 squared is 9, and 3 to the negative square is 1/9, right? Right. Yes. So this is just a third squared, which is 1/9, reciprocated. Well, if you reciprocate that, you get 9, right? 9 over 1. Okay. Yeah, tough question, but fair. All right, do we want to see 162? Yep, okay, cool. This is 8 times 8 times 5 more 8s. If you write it out, you won't make this mistake. This is 8 to the what? 7th, yeah. It has to be, right? I mean, there's 7 8s there, so it has to be. This one right here is 9 times 9 times 9 times 9 times 9 times 9. Let me move this over so I can hear a little better. And if I divide it by 9 times 9 times 9, how many terms do you see? 1. 9 divided by 9 is 1 over 1. 9 divided by 9 is 1 over 1. 9 divided by 9 is 1 over 1. If you thought, I'm going to do my own thing, right, and it hasn't been working for you for all semester, maybe try not doing your own thing because your own thing doesn't work, right? Maybe it works in general, but it doesn't work for you. Do this thing. This will work for you. We'll get 9 cubed on top, and that's it, yeah? Right? Don't we get 1 times 1 times 1, which we can ignore? 9 times 9 times 9 is 9 cubed, divided by a bunch of 1s. That's just 9 cubed. So x is 3. This last one, x was 7. Over here, we have 13 cubed to the 4th. What does it mean to take something to the 4th? Exactly. Do you see how I multiplied by itself 4 times? So now how many 13s are multiplied here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 13s are being multiplied here. This is 13 to the 12th, isn't it? That makes sense. That just makes sense. There's no secret trick here. It just uses the same logic we always do. Anything to the 4th, you times by itself 4 times. Oh, no, it's a weird number to the 4th. Dude, I could have written Batman signal to the 4th, and it would have meant Batman times Batman times Batman times Batman. That's what it means, right? So don't freak out. Just write down what it means. I know Adeline really likes Batman. I usually use that Batman analogy every year, but it's especially important this year because we have Batman in class with us. All right, are these the same, yes or no? This one's going to come out to what? It'll be 16. 2 times 2 times 2 times 2, and we know it's going to come out positive, right? Because there's an even number of negatives, right? Make it negative, make it positive, make it negative, make it positive. It's going to come out positive. This is the negative version of 2 to the 4th. 2 to the 4th is 16. What's the negative version? Negative 16, yeah. So they're different. In theory, there are ways to make this the same. Like, for instance, is negative 2 to the 5th the same as negative 2 to the 5th? It is actually, right? This means negative 2 times negative 2 times negative 2 times negative 2 times negative 2. That's going to come out negative, right? 5 negatives. It'll be negative 32. And this is 32. Make it negative. So sometimes it is the same, right? But this one was not. All right, flip it over. Next page, page 9. Page 9. We've only got a couple pages left, and we're done with chapter 1, which is like the longest chapter. Anybody want to see these? Come on, be honest. We can do all of them. We've got time. Okay, this is the cube root of negative 144. Do not tell me the answer is 12. This is a cube root. I bet you do know this is negative 12 times 12, though, right? Good. If you didn't know that, do 2 times 72 and just keep breaking it down, right? Eventually you'll get there. This is negative 3 times 4 times 3 times 4, yes? Now we get negative 3 times 2 times 2 times 3 times 2 times 2. Hey, look. I know the cube root of this. What's the cube root of 8? It's 2. Am I going to be able to cube root any of this other stuff? No, there's not 3 of them, right? So there's nothing to do with the rest of that. So what do I do with it? Well, it still needs to be cube rooted. I cube rooted those 2's, right? So it's out here. I need to cube root negative 3 times 3 times 2. That comes out to negative 18, right? So I'm just left with this. Turns out negative 144 doesn't have a nice cube root. That's fine. Plenty of things don't come out to nice numbers, right? Think about when you're dividing. Does everything have a nice third? 9 does, 6 does, 3 does, 12 does, 15 does. But does 8 have a nice third? No, it's 8/3, right? Sometimes it's going to be weird numbers. That's how you deal with it. The idea is you want to root as much as possible. I rooted as much as I could out of it, and there's nothing left. What about 800 to the half power? Let's do it together. That's this. Give me 2 numbers that multiply to 800. 2 and 400. All right, 2 I can't mess with anymore. Give me 2 numbers multiplied to 400. How about 20 times 20? Why do I like that? I know the multiplicative half of this, right? This one's half, right? What's the multiplicative half of this? 20, right? It shows you the whole thing. Half of it's just one of them. So it's 20 times the root of 2. Obviously, the root of 2 we can't simplify anymore, so we just leave it like that. What do you know? Pretty crazy, huh? Was it pajama day for the middle schoolers? Yeah? Flannel day. Oh, I missed flannel day. That's so sad. Dom, you looking like me. All right. I used to have hair just like Dom's, actually. Like, that's what it looked like right before I went bald. That's crazy. Yeah, I know. Maybe you'll be walking the same path as me. I was bald by age... How old are you? How old are you, Dom? How old are you, Dom? Oh, I was bald by 15, so you got 2 more years. All right, how do we deal with this? Here's what this means. This means we're going to take 16 to the half power and then cube it. Do you see how this multiplies to 3 over 2? Now, this is a better way of thinking about it, because 16 cubed is like humongous big, right? I don't want to do that. But what is 16 to the half power? What's the half power of 16? 4. So now all I got to do is 4 cubed. Does anyone know what 4 times 4 times 4 is? It's 64, yeah. A lot of you guys probably don't know 16 times 4 off the top of your head, because that is 4 times 4 times 4 again. But, like, these numbers are going to come up so often that you're going to memorize them on accident. All right, so how can I think of this one differently? Hey, oh, by the way, could you see any of the stuff I was doing earlier? Yeah. Okay, good. Please yell at me if not. How do I think about this one differently? Yeah. Uh-huh. And then squared, yeah. Nice job, nice job. So we need the multiplicative third of 27. Turns out it's a nice number. What do you times by itself 3 times to get 27? It's 3, because 3 times 3 is 9, times 3 again is 27. So really we want to know 3 squared. Hey, look, that's 9. Now think about this. This is 2/3 of 27, right? If it was 1/3 power, we'd ask this question, right? And the answer would be 3 if it was 27 to the 1/3, right? Wouldn't 2/3 be this then? 9. What would 3/3 be? 27, the whole thing. What would 4/3 be? What would 27 to the 4/3 power be? It'd be 81. It'd be a third of it, 2/3, 3/3, and then another third, right? So it'd be 3 times 3 times 3 times another 3. That's what. Oh, you can't see it. 27 to the 4/3 power would be 81. 1/3 is 3. 2/3 is 9. 3/3 is the whole thing, right? 4/3 would just be another one of those guys, right? So, yeah, that's all it is. It makes sense. Negative 1 to the 5/3. We can think of it like this. It doesn't matter what order you write them in. You can do fraction, outside, inside, whatever's easiest for you. I've been doing fraction inside first because the fraction makes number smaller, small number easy, right? But here, what's negative 1 to the 5th? Negative 1, right? Think about it. Negative 1 times negative 1 times negative 1 times negative 1 times negative 1 will come out or negative, right? And then what's the multiplicative third of negative 1? It's negative 1. Negative 1 times negative 1 times negative 1 gets you negative 1. Okay. So now we've got negative 3 either to the 1/3 power first or we're taking it to the 4th first. I think we'll take it to the 4th first. Then we'll take it to the 1/3 power. And then we'll take it to the negative first, which is the same thing as the negative. Okay? So what's negative 3 to the 4th? So that's 81. Let's use colors so we can keep track of this. If this were calculus, I would have already been using colors. Man, I miss teaching calculus. Calculus is fun. All right, so this is 81. And then we got to take 1/3 of it multiplicatively. And then we have to take it to the negative first, right? Which just means reciprocal, right? We talked about that, right? Divide, just 1 over whatever. 81 to the 1/3 power. 81 to the 1/3. That's not a nice number, is it? So let's do that. That's this. And then eventually we'll take it to the negative first. That's easy. Just make it the reciprocal, right? So let's write this out. What numbers multiply to make 81? 9 times 9. I'm going to write that as 3 times 3 times 3 times 3. So I can take 1/3 of this, can't I? I can take 1/3 of this part, right? What's 1/3 of this part? 3. So I get 3 times the cube root of the 3 that's left over. All in the negative first. How do I take it to the negative first? 1 over 3 times the cube root of 3. Right? This means divide by this once. So I did. I divided by it once. So let's back up and run over it again. Take it to the 4th, take it to the 1/3, take it to the negative first. Do it in any order you want. I did 4th first. I got 81. That way I can take 1/3 of it. I got as much out of it as I could, right? One of the 3's gets out, 1 3 stays behind, and then this says divide by it once. Okay. That's it. That was one of the hardest ones. Okay, cool. Now I'm on page 10. Is there a positive or negative number that equals 4 to the 1/4? In other words, is there a number that exists that gets you 4 to the 1/4? Probably, yeah. It's going to be nasty, right? But it'll exist. It's like 1 and change. Think about it. If it was 0, well, we'd do 0 times 0 times 0. That wouldn't work, right? 0 is too small. 1. 1 times 1 times 1 times 1. That's going to get us 1. That's too small, right? What about 2? 2 times 2 times 2 times 2, that's 16. Too big. So it's got to be 1 and change, right? So yeah, there's a number that exists. Sure. It's just awful. And that's why we write it as this, the 4th root of 4, or like that. We don't want to write 1 and change, which is a nasty number to write. It goes on forever. We need a calculator to figure it out, or we got to do a really nasty algorithm that Newton invented. So we just have this symbol for it. It's kind of like pi, the symbol, right? It's shorthand for that awful number. This is shorthand for whatever this number is. So it does exist. How come this one doesn't, though? This does not exist. Yes. Why does that matter? Think about it. If all of these have to be the same number, either they're all going to be positive or they're all going to be negative, right? So if they're all positive, will a positive times a positive times a positive times a positive get us a negative? No. So imagine all the numbers are positive, right? Whatever this number is, 1 and change. That's not going to work. Well, what if they're all negative, right? Negative something, negative something, negative something, negative something. Will that come out negative? No. So there's no number that exists that can get you the multiplicative half of negative 1/4. Either the number we're looking for is positive, right? But all positives don't multiply to a negative. So that doesn't work. Or the number we're looking for is negative, which means they're all negatives. But if these are all negatives, won't it come out positive? It's impossible. Turns out there is a number that exists. You just don't know it yet because it doesn't exist on the number line that you would know exist. There's another number line that's always been there that you did not know exists, and you're going to learn about it in Algebra II. There are numbers that have to answer this question, not just because we really want it to, but because all the other numbers don't make sense if this doesn't work either. It was a huge crisis in mathematics for like 300, 400, 500 years, and eventually somebody solved it. We're going to talk about what that is. Once you have that last bit of numbers, you'll know all the numbers you need for algebra. There are other numbers, but they're kind of even wackier. Like these numbers are normal. They're just weird to you because you haven't seen them yet. Kind of like when you first didn't know about decimals or didn't know about fractions or negatives, right? They existed. You just didn't know about them yet. All right, down here, without a calculator. Fam, isn't this 2 times 15 to the 4th power times 2 times the 4th power? This is just 2 to the 16th over 4. Right? Right? We know these add. That's 2 to the 4th. What's 2 to the 4th? 16. Ah. Yeah, he does that in class all the time, Adeline. You'd really like second hour. All right, now we have this, right? Fam, do you see how 2 to the 5th and 10 are supposed to multiply? What's 10 divided by 5? 2 over 1, so we get 4, right, for our exponent. We have negative 3 to the 4th. Now, there is something kind of weird here. Whenever you do that, you have to treat the number that it was doing it to as if it were in parentheses. This is actually going to come out positive 81. I would have also accepted negative 81 because you might have thought, well, wait a minute. This was inside the parentheses. This multiplies and I get 2 times 2, right? This is an ambiguous case. Ambiguous means you're not sure what it means, which is a funny word to teach kids because you're like, what does ambiguous mean? And the kids are like, I don't know. And you're like, yeah, exactly. You're right. And they're like, what? Yes. So I would take 81 or negative 81 there. You have to be really specific about what you're doing with your calculator when you do that stuff. All right, next page. Do you want to see it, yes or no? Okay. The root of 600. Give me 2 numbers that multiply to 600. 6 and 100 is pretty good. Why do we like 6 and 100? We know the root of 100. That's perfect. What's the root of 100? So we get 10 root 6. Now, think about it. Think about it. Can we break down 6? Yes. We break it down into 2 and 3. Do we break it down into 2 2s? 2 3s? No, so we're stuck, right? The root of 6 isn't nice. You break it down in 3 and 2 and you get stuck, right? So it's 10 root 6. Oh, no, it's a decimal. Did you know that 1.44 is the same thing as 144 over 100? Lexi knows this. It's the same thing. 1 and 44 hundredths, right? This is really easy to think about. What's the root of 144? And what's the root of 100? Wow, 12 tenths. Or if you would like 6 over 5. Yeah, you can factor out a 2 and divide out, yes. Okay, cool. This page is kind of big, so I'm going to zoom out. All right, the root of 2 to the 4th power. What does it mean to take something to the 4th? These are all the same root, so we can multiply them. It's all one term. This is the root of 16. What's the root of 16? Makes sense, doesn't it? Isn't this the multiplicative half of 2? Isn't this the other half of 2? So what happens when I multiply them? I get 2, right? It's 4. Right? Here's half of it times its other half. Doesn't it get you the whole thing? That's the idea. This is the root of 4. What's the root of 4? 2. Or you can multiply them together first and get root 16 and get 4. Doesn't matter. This works for multiplying and dividing. It does not work for adding. So if I had root 2 plus root 2, remember we're talking multiplicative halves. In order to get back to the whole, you have to multiply, not add. Hey, what's up? Knock, knock, indeed. Abigail's a little behind on the stuff. She's been sick lately. Can I interest you in any of this stuff? No one asked. Yeah, of course. All right, dinguses and binguses. We have the root of 49 made negative. What's the root of 49? So this is really negative 7 cubed. Is it going to come out negative or positive? Negative. Thank you. I don't think we should abbreviate it like that. This is just, now that we got that done, we have 7 times 7 times 7. This is 49 times 7, right? All right, what's 50 times 7? 350, right? So what's 49 times 7? It's 1 less 7, right? You guys see this? 57s gets you this. This is 1 less 7, so it's 343. 1 less 7. So there's your answer, negative 343. Yeah, it's 1 less 7. A lot of you probably still don't see it, but when you do, it's going to change your life. This means 57s, and I know that because that's easy. So if I need to know 49 sevens, all I got to do is subtract 1 more 7. That's what multiplication means, right? Repeated 7s being added or subtracted. All right. We are nearly done with chapter 1. We got one more page, and then we have the advanced ones. I'm going to come back to the advanced later if we have time. Okay? So this is asking for the 5th root of these guys. Does anybody know the 5th root of 32 off the top of their head? It's 2. It is. You could break it down into 16 and 2, and then you could break it down into 8 times 2 times 2. Eventually you get 5 2s. So this just becomes 2. And then the fifth root of 243. I don't know it off the top of my head. Here's the problem. Is 243 even? No, so we can't write it as 2 times something. But we can write it as 3 times something. And here's how I know. 3 times 80 gets me 240, right? So this is 3 times 81. And a lot of you guys are realizing already that's going to be 4 3s here and 1 3 there, right? 3 times 3 times 3 times 3. Isn't this 81? Right. 9 times 9. So I want the multiplicative fifth, right? What's the multiplicative fifth of this? 3. So this is 2/3. It's really about how you see it, guys. That's the thing. It's about how you see it. Oh, no, it's a decimal. Can somebody give me this in fraction form? -1 over what? That's tenths. That's hundredths. That's thousandths. Yep. Thousandths place. Turns out that whole like place value thing that they were trying to teach you in the middle or elementary school, middle school, you didn't pay attention to is really important. That's 1,000th. It's a fraction. So we root both. What's the cube root of -1? What do you times by itself 3 times to get -1? -1, that's easy. What do you times by itself 3 times to get 1,000? 10, yeah. Look at us, right? Right? That's not so bad. Do not take 1,000 and divide it by 3 and give me 333.33 repeating. Do not do that, Dom. All right, 183 is weird because words hard, math easy. Suppose that n is a positive number. Okay, cool. It's a positive whole number. What must be true about n if you're not able to simplify it? So, for instance, can I simplify this? What's cube root of 1? 1. We can simplify that. Can we cube root 2 and simplify it? No. What about the cube root of 3? No, we cannot. 1 times 1 times 1 does not get you 3. What about the cube root of 4? No, we can break it down into 2 times 2, but there aren't 3 2's there, are there? What about the cube root of 5? No. Cube root of 6? No, we get a 2 and a 3. What about the cube root of 8? Yes. Why can we break down 8? Because we can write it as 2 times 2 times 2, 3 numbers. We could break down this one because we could write it as 1 times 1 times 1. So if you're unable to simplify something that looks like this, that means there aren't 3 repeating factors. Does that make sense? I have 3 repeating factors in 8. That's why I can simplify it. I have 3 repeating factors in 1. That's why I can simplify it. Cube root of 6 only has a 2 and a 3. No repeating factors. We don't have 3 of them, right? So that's why. Put that into words. I don't care. Ooh, we can just add and subtract all these. Yeah. No. You can't. I'll prove it to you. I wish it were so, but it's not true. It's not because I said so. It just literally doesn't work. Gritty, we're going to use some roots you do know. So let's use 16, and let's use the root of 9. Okay? The root of 16 is 4. The root of 9 is 3, right? So this should add to 7, right? Right? Now, what if we try to just add them first? What's 16 plus 9? So one of these can't be right, right? Do you guys see this? How this is the root of 25, which is 5, and it's supposed to be 7, clearly. So it just doesn't work that way. You can't add them like that. You have to root them first. Multiplying, dividing, do whatever you want. But adding and subtracting, you have to root first. So let's root this. Let's do it in our heads. Isn't this 6 times 2? Isn't it 4 times 3? I like 4 times 3 better. Why? So what is the root of 4? And the root of 3 we're just left with, right? So this is 2 root 3. Root 75. Give me 2 numbers that multiply to 75. No. 25 and 3. Why is 25 and 3 nice? Because I know the root of 25. What's the root of 25? Hey, stop. What's the root of 25? 5. And what's the root of 3? Root 3. We're done. Hey, we can add these together now. Check this out. How many root 3's do I have now? 7 root 3's. It's okay. Okay, we cannot just subtract the root of 245. We need to convert it to something that hopefully has root 3's. If it doesn't, we'll just leave it alone, right? 245. What 2 numbers make 245 when you multiply? 5 and something, right? 5 times 20 gets me 100. 5 times 40 gets me 200. 5 times 49 is 245. Fam, why do I like 49? So this becomes 7 root 5. Now I have a problem. Are these both the same kind of roots? They are not, so I have to leave them like this. You could also factor out a 7 if you really wanted to and write it like this, but you're never, ever, ever going to be able to combine root 3 and root 5. Sorry. So either of these work. Now imagine this was 7 root 3 minus 7 root 3. What would 7 root 3 minus 7 root 3 be? 0. What if it was 7 root 3 minus 5 root 3? I had 2 root 3, right? But in this case, we can't combine them anymore. That's just how it goes, okay? These were combinable because they're both root 3s. These are not combinable because they're not the same roots. Sorry. If you think about it, it's like 2x plus 5x is 7x, right? This is like 2x minus, or sorry, this is like 7x minus 7y, right? You can't combine those. All right, cool. What x is going to make this correct? 5 to the half power is what we have here, times 5 to the what power? 1/4. There's a difference. Equals 5 to the what? Well, we know these add, right? We need common denominators. How many quarters are in a half? 2 quarters. So how many quarters do I have in total? This is the same thing as 5 to the 3/4 power. Pretty slick, huh? Hey, guess what? That was the last page for chapter 1. The longest chapter, the hardest chapter. That's it. We're done now. Intermediates are done. Basics are done. If you want to go back and get the advanced ones, we'll do that at the end, or we'll do it at the beginning of the next session because it's also Algebra 1. I know Emma said she's going to be here at 6 to 9. I don't know if anybody else is. I hope Harper is so I can question her about the theft that happened in my room earlier today. What? Maybe. Go quick. Oh, my God. Everybody flip the quiz, too. Start thinking about which ones you want to see. Okay, maybe it just sucks, right?
I got it here. Do I have to finish it?
Question. Did you pick 2 equations, get rid of 1 variable? By elimination or substitution? That's what you need to do here.
I did. What did I do?
You got down to 2 variables, that's good. And then did you get down to the same 2 variables here, y and z? You did. So move that over. So you need to get this to be something with y and z in it, and this to something with y and z. And then once you get there with both y and z, you can be done. I want you to get me a system that has this equation and whatever this becomes when you get y and z together. I don't know. You might be on the wrong track here. We're going to review that today. So you could just wait till then. Hey, I don't want this. Sounds fantastic. I think that's a great idea. All right, friends, Romans countrymen. Anything on page 1? No. On God? What's the answer to this one? It's 6. Hey, pro tip. I am tired of you guys not plugging stuff in and writing it down like this. Haley and Mo, I'm talking to you. Stop doing individual stuff, okay? If you write it out, you won't make mistakes. I'm going to do 2, 2, 1, and 2, A and B. This says atom. We are not moving things across an equal sign. 3x's plus 5x's. How many x's? Thank you. If you want to, you can think of it like this. 3x minus 8, and we're adding it to 5x plus 7. Do you see how this is 8x's? Yes or no? Go ahead. Where are you going? Okay, thank you. Now, what is negative 8? Yes, you do have to pay attention to the signs here. If you don't pay attention to the signs, you're going to make a mistake. That's the one thing you got to do in this problem. Everybody's like, I'm just not going to pay attention. And then it goes poorly. What's negative 8 plus 7? Negative 1, right? If you're down 8 and add 7, you're still at minus 1. Do you guys see that that's what you get over here too? Cool, awesome. What are we doing here? Atom. 3, and we're adding it to 27. What is it? Good. And what's negative 3x's plus negative 19x's? Negative 22x's, right? Dominic? Okay. Here we go. How many t's are being multiplied here? It's t to the 7th, has to be. Y to the 5th times itself 9 times. How many y's are going to be multiplied? 5, 5, 5, 5, 5, 5, 5. 45, right? Everybody tells me x to the 7th here, and then they goof up the next part. What is 16 times 4? Yeah, it's that simple. Show your parents this video, and your parents are going to slap you up the backside of the head being like, why are you so dumb? This is easy. They will beat you. They're being like, this is what you said was so hard? Yeah. All right, fun fact. We're going to get 3 times itself 6 times, and x, that's ugly, x squared times itself 6 times. So that's 12 x's, right? 3 to the 6 is an awful number. Normally, I won't make you have a number that big, okay? But that's just going to be 81 times 9, which is ends in a 9. It's 729. I'll accept either because 3 to the 6 is kind of awful. But I'm your calculator, right? So there you go. 81 is 3 to the 4th. 3 squared is 9, so if you times 9 and 81, you get 3 to the 6th. All right, fam, all the p's divide out here except what? 5 of them in the top, right? So we end up with this. Yes, all the p's divide out to 1s in the bottom. All the p's divide out to 1s in the bottom. 2 of the p's divide out to 1s in the top, and we're left with just p to the 5th over 1, which is just p to the 5th, right? All right. 25 over 30. I'm going to write it as 5 times 5 times z cubed over 5 times 6 times z cubed to the 4th. Or z cubed times z to the 4th. Do you know why I wrote this out this way? I factored it, so now I can easily divide out like terms. All of the z's divide out in the top. 4 are left over in the bottom, right? So hopefully you can see 25 over 30 simplifies to 5 over 6. And z cubed over z to the 7th simplifies to 4 z's left over in the bottom. If you make that z negative in the bottom, negative z to the negative 4th, it is wrong. Z to the negative 4th in the bottom is the same thing as z to the 4th in the top. If you wrote z to the 4th up top and you made it negative, that's okay, because that means z to the 4th in the bottom, right? But pick one. What does 3 to the negative 1st mean? Thank you. Do you see how we no longer have negative exponents? You did it. What's 5 to the negative 3rd? Yeah, thank you. Or 1 over 125. But you don't need to know what that is. I just said no negative exponents. So if I gave you 5 to the... if I gave you 5 to the negative 19th, that's 1 over 5 to the 19th, right? I do not want to see you sitting there figuring out what 5 to the 19th is. I've seen so many people spend like 10 years trying to figure that out. And it's like, girl, it just said make the exponents not negative. Expand. This means multiply. So we're going to do 2 times everything, right? This is 2 times all that. Well, if I times it, I'm going to get 2 times this is going to get us 4t minus 14. Are we on the same page? Yeah. Excellent. Now, it says take x times everything. Well, what's x times x? Thank you, x squared, not 2x. 2x means x plus x. What's x times 9? Positive 9x. It's distribution. You hit every term, right? Factoring is the opposite of that. So check this out. If I gave you this, couldn't you take out a 2 from both and put it here? That's factoring. So what can we take out from 12a and negative 18? We want to take out the biggest number possible. 6 is the biggest number possible. I'll prove it to you. Do you see how what we're left with, 2 and 3 have no more common factors? There's nothing else to do. This is what I want. What I do not want is this. Do you know why we do not want this? We can take out another 3 from everything, can't we? And then we get this, which guess what is that? You have to fully factor it. Cool. What do 7x squared and negative 30x have in common? They have a factor of x. That's it. 7 and 30 have nothing else in common. So what we're left with is this. You can always check your work by distributing. X times this gets us back, right? Are you guys seeing that? Cool. That's factoring. You don't divide. Dividing would be getting rid of the 6 or getting rid of the x. That changes the problem. These are not equations. They're expressions. What do we need to be able to put these together? We need common denominators, right? So check this out. They are almost the same denominator. All this guy needs is another x. That's right. So what I'm going to do is times by x over x. What is x over x? 1. So timesing by x over x doesn't change anything. It's totally legal. I get 6 times x in the top, and I get 7x in the bottom. That's what I wanted. Now that they're both being divided by 7x, you can think of this as kind of like distribution. This is saying divide everything by 7x. Do you see if I distribute that divides by 7x, I get back to here? Yeah, you can distribute division. Did you know that? That's crazy. They have kami to nami, so you can write it like that. How we feeling? Well, I think it is, once you know what you're doing. Hey, look, here's the thing that everybody's going to do individually. They're going to, like, take 3 and square it. They're going to write 9, and then they're going to add 1 and write 4. Then they're going to square it and write 16, and they're going to put 9 and 16 together and get the answer. That's best case scenario because then they get the answer right, but then they forget about the root. Here's what you need to do. Stop being babies. Write parentheses, you cowards. R is 3. Whenever you see an R, replace it with a parenthesis. Sometimes you're going to have double parentheses. Oh, no. Stop crying. Okay? So now we're here. Does that make sense? Wherever you replace a variable, wrap it in parentheses. If you don't do that, you're going to get your butt kicked really soon at the end of Algebra 1 and Algebra 2. You can't just do things individually. Sorry. It takes a million years and you make a million mistakes. Do not forget there's a root here, everybody. So, what is 3 squared? 9. Do not square these individually. You can't square stuff individually. 3 plus 1 stands for what? 4. 4 squared is 16. If you square individually, you get 9 plus 1. That is not 16, right? If you square individually, you get 9 and 1. You can't do that. This is 4 squared, which is a fun game to play outside, but it is also 16. So we get the root of 25. You cannot root these individually. Remember we talked about it earlier? You can't get 3 and 4 and get 7. That is not how this works. This is 25. What's the root of 25? Thank you. Stop doing dumb stuff. All right, how many terms do you see here? 2. We have 5 times whatever r is divided by 3, and then we have a separate term, minus 9 divided by something. If you write it like this, it's a lot clearer. I like writing my stuff like this, but you need to be able to know how to read it because people like to write their equations really poorly. This is the equivalent of a mathematician, if a mathematician writes something like this, it's the equivalent of like an English major or like an English person writing with bad grammar. And then they're like, how come you didn't understand what I was saying? It's obvious. Use better grammar, idiot. Okay, that's how mathematicians feel about slash bars. If you write it like this, it's really obvious how many terms there are and what you need to do. So you need to know how to read it because morons like to write stuff like this. This is why you see this stuff on Facebook where it's like, Chinese 5th grader can solve this, can you? And everybody's saying like 12 different answers, right? It's not actual math. It's stupid. It's calculation and it's a bunch of baloney. Just write your equations better, idiots. All right, what do you notice here? 3's divide out. Thank you very much. So we get 5 times 1, which is 5. Hey, look, 9 divided by 3. What's that? 3. So it's 2. Again, I write it like this because the book writes it like this. Why does the book write it like that? Because you need to know how to read people's awfully written equations and expressions. Should you ever write something like this with slash bars? Oh, my God, please no. God, no. If you type that into a calculator, your calculator is going to think something completely different. Okay? Write this. Hey, look, s is -4. Here's where everybody does squaring it and then forgets the negative. Also, there's a plus sign here because this quiz it auto-corrected to an equal sign. But yeah. So anyway, one of these days I'll sit down over the summer and fix all these. I keep telling myself I will. But yeah, what you need to do is replace wherever you see an s with parentheses. Do you see how that minus sign is on the outside of it? And the 4 is on the outside of it? What? Are you excited? I'm talking to Lexi. She's back in the game, guys. Hey, look, we're supposed to plug in -4 for s. Guys, this means I want the negative version of s squared, right? What is -4 squared? 16, but I want the negative version of it. It will be -16. This will come out negative. Negative what? Hey, look, that's 0, right? No. Everybody keeps telling me this is 0. -16, go down 16 more. Where are we at? -32, go down 12 more. -44. Sometimes it does go away, depending on the version of the quiz and how evil I feel. All right, this is divided by 3. Cool, it's all one term. We have whatever s is, -8 divided by 3. Those extra parentheses let you know that we're not dividing 8 by 3, but this entire thing. So s is -4. Fam, what is -4 minus 8? And if we divide it by 3, it's going to come out -4. These are intermediate questions. This is impossible. There's no way anyone can pass this class. Guys, by the way, if you can do the basics, you automatically pass with a C. If you did all the homework. If you didn't do all the homework, you get like a 68. If you did none of the homework. So to ace this class isn't even that hard, turns out. You just have to actually do crap. I don't understand any of this stuff, Mr. Mack. I don't do any of the homework. I don't participate in class. I sleep the entire time and don't actually ask questions. How come I don't know anything? Well, that's clearly on me. So, fam, you can divide or multiply first. Gritty likes to multiply first, so I guess we'll do that. This means 4 times 2, which is 8, and x to the what? 8th. This is x times 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 x. If you stop and think about it, you would never say 15. But if you're trying to do tricks, you're going to make a lot of little mistakes and look like a moron. All right, now we have this. Oh, by the way, serious moment. I've been playing a character up to this point, right? I play a character on TV. My actual self, this is really me. Do you know one of the reasons I decided to like call you guys morons and stuff occasionally and like be mean to you? Because every teacher growing up, and I know this is true for you guys too, they will tell you, good job, blah, 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 and you never believe them, even when they're telling you the truth, right? So if I tell you you're being a moron when you actually are being a moron, when I tell you you're doing a good job, you'll actually believe me. And that's super important for me. I need you to know that I actually do care and love about every single one of you guys. And so when I say that, I need you to believe it. Does that make sense? Cool. So when you're being a bozo, I'm going to call you out, okay, because that's the right thing to do. But yeah, I do love and care about every one of you guys. 8 to the x to the 8th divided by x to the 4th. Don't all the x's divide out except for 4 of them? So we're going to have 4 x's left over in the top location. All right, 8 and 6. What common factor they share? Dose. So after the 2's divide out, we get 4 and 3, yeah? All the x's divide out except for 4 in the top. It's that easy, Gritty. Yeah, I know. Yep. It's just simplifying fractions. I know. It's that easy. The 2's divide out. I'll write it out. This is 2 times 4 times x to the 4th. This is 2 times 3 times x to the 4th times x to the 4th, right? Isn't that what this is? Wait, hold on. I goofed it. Isn't this the same as this? 2's divide out to 1's. X to the 4th divide out to 1's. And we get 1 times 4 times 1 times x to the 4th. 1 times 3 times 1. Cool. All right, over here, divide or multiply in any order. Yeah, I'm going to do that. There is no trick here. As soon as I do this, you guys think, oh, cross-cancel or something. Stop. As soon as you think that way, you make mistakes. Okay? If you cross-cancel, you will get this one right, but you'll get every other one wrong when you use it when you're not supposed to. So stop thinking cross-cancel. Here's what this is. Do you see it says we're supposed to multiply by this and that? Do you see we're supposed to divide by this and that? How many terms? 1. So do it in any order you want. What is 24 divided by 3? Pause. Stop. Notice how I'm not doing 15 divided by 3. Right? Because that's not what it said to do. It said divide this stuff by 3 and 15, right? So 24 divided by 3 works out nicely. They cancel, but they don't go away. What's 24 divided by 3? 8 over 1. If you do that, you won't make mistakes, which is why you guys are going to be like, I'm going to do my own thing, and then you're going to make mistakes. And your parents are going to be like, why is this so hard? Is 5 divided by 15 going to get us 3? No. What is 5 divided by 15? 1 over 3, yes? Right? 1, 3. You would not believe the number of people that tell me 3 over 1. Location matters. It's not rocket science. Hey, look, don't we have t cubed divided by t to the 4th? How many t's will be left over? How many t's will be left over here? 1 t in the bottom, yes? Cool, we still need to multiply all this crap. All right, 1 times t to the 8th is just t to the 8th. 1 times t to the 6th, t to the 6th. How many t's are going to be left over after they divide out? 2 where? In the top. What's going to be in the bottom? It's all going to divide out to 1's, right? These divide out to 1's. This divides out to t to the squared. These all divide out to 1's. This divides out to t. So now we have this. Hey, look. This says divide by t, 3, and 1. Dividing by 1's easy. Can we divide any of the top stuff by t? We can, right? This is all one term, so we can do it. If there's a plus sign here, you definitely can't do this, which is why I tell you not to think cross-cancel, because you love to do it when there's plus or minuses here. Because it's all one term, because it's timesing. What is t squared divided by t? This becomes 1. This becomes t. So now when we multiply, we get 8t over 3. If you simplify before you multiply, it's really easy. Simplification is for you, not your teacher. Simplify first, and your life will be a lot easier. How do we simplify? Well, we divided first. Why divide? Because dividing makes numbers smaller usually, and that's better. Hooray, lots of stuff divided out, and then we just got this. Cool, all right. Are you ready for this one? It says no negative exponents allowed. How do we switch that? Well, doesn't this mean divide by x 3 times? So we want to divide by x 5 times and divide by x 3 times. You could circle that, but this is really x to the what? Duh. Hey, look, this says divide by x to the divide by 1 over x to the 4th, right? You can think of it like this. This works. This totally works. Isn't that what that means? 1 over x to the 4th? Right? Yeah. However, you should know that dividing by 1 and dividing by x to the 4th, it just means this. Dividing by a fraction is the same thing as multiplying by its reciprocal. Do you see the reciprocal of this? Crazy, huh? Dividing by a negative exponent is the same thing as multiplying by a positive exponent. Timesing by a negative exponent is the same thing as dividing by a positive exponent. What do you know? Nobody reads this. Write it like this. This is going to be 2 times 2t minus 7. Are you seeing it? Yeah. That's the form I want. I don't want anything else. Don't distribute. This is 3 times 2t minus 7. This is 4 times 2t minus 7. Next page. Which ones do you want to see? I don't care about this. I don't care about this. All right, let's do it. Now we're doing roots, but now they have variables in them too. This is 4 times 24 times t squared times t squared times t squared. Are you seeing that? T to the 6 is t times t times t times t times t times t. Why did I write it like this? Yep, and that's 6 t's. But I want the multiplicative half. What's the multiplicative half of this? What's the multiplicative half of this? What's the multiplicative half of this? I'm going to show you an easier way in a second. So that's just t cubed. What's the multiplicative half of this? Isn't 24 the same thing as 4 times 6? What's the multiplicative half of this? So we get this. So all together we get 4t cubed root 6. Reminder, you cannot use notes on the final, so you better freaking study. All right, can I show you an easy way to do this? What is the multiplicative half of t to the 6th? T cubed, right? Isn't t cubed times t cubed to the 6th? Awesome. And then you can break down 96 how you want. You don't have to do it individually like this. Right? T cubed is half of it, right? Over here, what's a third of x to the 12th? Good. So now we're here. Does anybody know the cube root of 125? It's 5. If you didn't know that, you could write it out like this. It's definitely 5 times something. 5 times 5 gets you 25. 5 times 20 gets you 100. So 5 times 25 gets you 125. After you write it all out, it's pretty obvious that the multiplicative third of this is going to be 5. Nothing left over. Medicine's wearing off. That's not good. All right, turn to the page. Do you want to see it or no? Hey, what are we doing? What does it say? No, what are we doing? Think about it. What are we doing? What are we doing in this problem later? I'll record this and upload it and send you an email. You couldn't convince mom and dad to let you stay? That's amazing. Fam, what are we doing in this problem? What is it asking us to do? I know it says simplify. What are we doing? We're subtracting. Thank you. We're subtracting. Are we moving stuff over equal signs? No. So stop doing the opposite of what it says. 3x minus 4x is how many x's? Negative 1x. Are you smelling what I'm stepping in? 7 minus 9. We did it. You just have to read. You could also do this. Subtract it, you get negative x. Subtract it, you get negative 2. You just have to be careful about your subtracting. It doesn't mean add these. We're subtracting 7 and 9. They're both positive, so it comes out to negative 2. 7 minus 9 is negative 2. Over here, what are we doing? I swear to God. So another way you can handle problems like this, if it says subtract all this crap, well, another way to think of it is this. Here's this part. And then I'm going to minus r squared, right? Am I going to minus negative, or am I going to minus 7r? Yeah. And if I'm minusing negative 5, I'm really adding 5. It's kind of like distribution because it is. Do you know what negatives really are? Negative 1. This is timesing by negative 1 to everything. I know. Shocker, right? Now, check this out. What is r squared minus itself? Goes away. So that's 0. What's 3r minus 7r? Thank you. And what is negative 2 plus 5? You did it. That's the hardest one on here, guys. Although this one might be harder. You guys seem to make a lot of mistakes. What are we doing here? Thank you. We're subtracting negative t times t to the 9, or t plus 9. So let's distribute. What's 3 times t? 3t. What's 3 times 7? 21. Then negative t times t is negative t squared. Are you following me? Negative t times 9 is negative 9t. Are you following me? Yeah, we want to times everything by t and then subtract it. So I'm doing that. Times it by t, subtract it. Times it by t, subtract it. When we do this, we get negative t squared, because that does not go away. What is 3t minus 9t? Thank you. And then look, we have plus 21 left over. We've combined all our like terms. No, you cannot combine t squared and regular t's. They are not the same thing. They are not like terms. Turning the page. Anybody want to see these? Yes or no? Factor each of the following. What common factor do all three terms have? Try again. 4. You could have taken out a 2, but it wouldn't have been fully factored, right? That's the biggest number you can take out of it. Check by distributing. Negative 8t cubed, positive 4t, positive 16. What common factor do all these have? 9 is the biggest one, but there's also something else, and a z that you can take out. So you're left with z squared minus 3z plus 3. This one down here, why is this possible? Why are we allowed to divide separately? Distribution. You can distribute division. Divide both terms by 2, right? It's that simple. Dividing by 2 is the same thing by timesing by half. You can distribute times by half, so why can't you distribute divide by 2? Down here, simplify below. First, how many terms are in the top? What common factor do they have? If we factor that out, we can safely now divide by the common factor in the bottom. What's the common factor? 5. 5s divide out, and we get 1s. So what happens? We get negative x squared plus 5 over x. Do the x's divide out? No, because it says divide both terms by x. Are both terms divisible by x? No. That's why you always factor first, because then you can divide safely. Let's factor first over here. What common factor does the top share? 3r. This is 3r times r squared minus 7. All over, I'm going to write the bottom as 3r times 3r. Isn't that 9r squared? Hey, look. Timesing, dividing, timesing. These are all one term. I can divide these out safely now. So what do we get? We get r squared minus 7 times 1, which is just r squared minus 7. And in the bottom, we get 1 times 3r, which is just 3r. Do the r's divide out? No, not everything's divisible by r, so we don't do it. Oh, boy. What do we need to make these work? Yeah, so what can I multiply by that won't change the expression, but will allow us to have the same denominators? If we multiply by t over t here, and we multiply by 7 over 7 here, they're going to have 7t as a common denominator. That's good. I'm going to cut to the chase. They're both going to be over 7t, because, like, that's why I did it, right? Right? Like, that's why I did it. So it's going to be that. We're going to get 2t squared on the left side. And then we're going to add on. Do you see how there's two terms here? What's 9 times 7? What's negative 2t times 7? Negative 14t. Did it. It's all one fraction. That's all they wanted. This one. We need commie denomies. We're pretty close, actually. What do we need to multiply by to make these have commie denomies? If we multiply by t over t, won't we get 6t cubed here? How do I make this 6t cubed? Very good. And this won't change anything. We'll end up with a common denominator of 6t cubed because, like, duh, that's what we were trying to accomplish, right? The top on the left side becomes 6t minus 2, and the top on the right side becomes plus 5t. If you want to combine like terms, you can, but it just said make it one fraction, so I'm not picky. Right? These two can go together, right? Do it or don't, I don't care. It says make it a single fraction. Did we make it a single fraction? Yeah, so I'm good. Okay, down here. A lot of you guys love to distribute. Whenever you see the opportunity to distribute, you're like, oh my God, I have to distribute. And here's the secret. Distribution makes more terms. Did you know more terms means less simple? So if you don't have a good reason to distribute, why do it? This is x times x minus 1, right? So how do we make this x times x minus 1? How do we make these match? Dude, if this was x times 5, wouldn't you times this by 5? This is x times x minus 1. So what are you going to times it by? X minus 1 over x minus 1. Now the denominators match. I'll write this one out. This side is unchanged. This becomes this. Do you see how they now have the same denominator? Crazy, right? If they have the same denominator, we know that you can distribute division, right? So this becomes 3x plus 2 times the quantity of x minus 1. Can you distribute the 2? Yeah, but why would you? It said write it as a single fraction. What's the point? Stop distributing just for the fun of it. How we feeling? Did you know that we're done with 2 now? Did you know that 3 and 4 are basically the same thing as 2? Oh no, look, they have a variable, but it's equations this time. Oh no. Did you know 4 is the same thing as 3? It just has 2 variables. It'll have x and y in there. Oh no. So it's really easy. Are you ready to go fast? Anybody want to see anything on page 1? I'm going to stop holding your hand like I did for the first 2 quizzes. So if you don't speak up, we're not going to do it. You need to speak up if you need to see something. You know to multiply all by 4 to get rid of fractions, right? Yes, Haley? Part C. I would do that. All right, there's a couple ways of doing this. Some of you guys are like, ooh, 0.5's not so bad. However, to make it really easy, what if we times everything by 2? These are equations. You can do that. Yes, the numbers are going to get bigger, but as long as the equation is still true, who cares? This makes the problem a lot easier, doesn't it? Some of you guys actually goof up your subtracting 0.5s, so this is a way to guarantee you don't. If you want to add 6 to both sides, go ahead. But I'm going to do this. My general rule of thumb is if my variables all together, I should be able to solve it in my head. What do you add to negative 6 to get 7? 13. So what do we know? 2y must equal 13. Same thing you get if you added 6 over. All right, what do you double to get 13? 13 over 2. Stop thinking in decimals, Dom, because if this wasn't halves, you wouldn't be able to answer it. Imagine this was a 3, Dom. 3 times what gets you 13? Times up. 13 thirds. Imagine this is a 5. 5 times what gets you 13? There you go. Fractions are better than decimals. Stop relying on decimals. Check it out. 13 halves times 2 gets us 13, yes? If 2y is 13 and we minus 6 from it, we get 7. Ta-da, we win. The bottom one. Could you combine these? Sure, you could, but you could also times everything by 4 and just get this. Pretty easy, huh? What do you add to 3 to get negative 1? Got him. What do you add to 3 to get negative 7? So we know what? X must be negative 10, right? 3 minus 10 is negative 7. Dom, what do you times by 4 to get negative 10? Thank you, because the 4's divide out because it says divide by 4, and you get your answer. I'm right. Stop pretending I'm not. I'm right. I swear to God I'm right. You can trust me. Hello. Good. Proud of you. Okay. It's probably not. For the record, it's probably not no solutions. All right. 3, 1, 2. Any of these? Yes, no, maybe so? 4. Hey, Dom, what do you times by 3 to get negative 2.4? Wrong. Do you see how if I take this number and I times it by 3, the 3's divide out? And I get negative 2.4? Yeah, negative 0.8 would also work, but I really don't care. Hey, what do you divide by 4 to get 3/8? Does anybody know? 3 halves. Do you see if we divide by 2 and divide by 4, it's the same thing as dividing by 8? I'm sorry. I bought them from Amazon in bulk. You're welcome. The school does not provide them. All right, so do you see how 3 divided by 2 divided by 4 is the same thing as 3 divided by 8? If you don't see it, that's okay. What can we do to get rid of fractions? We can times everything by 4, right? So what do we get? Well, we divide out to 1. We get y equals 12 over 8. Do not times the top and the bottom by 4. We did not times by 4 over 4, did we? No, we times by 4. Multiplication happens at the top, division at the bottom. We get 12/8. Hey, guess what 12/8 is? It's 3 halves. Belt. Why is this problem hard? Division. Why don't we times everything by 9? That divides this out, doesn't it? Are we timesing by 9 over 9? No, so do not times by 9 over 9 over here. This is negative 72. Hey, Dom, what do you times by negative 4 to get negative 72? Try again. That works. If you want, the negatives can divide out. If you want to simplify, you can do that too. 18. That's smart. All right, fam. You can either multiply by 5 to get rid of decimal or fractions, or you can think this. Something divided by 5 is 3. Fam, what divided by 5 is 3? So you know what? X minus 2 must be 15, which means X needs to be 17, right? You win. Bam, you can totally divide everything by 6 here or distribute the 6. However, this means 6 times something is 36. What times 6 gets you 36? So what do we know? No, r minus 8 equals, which means r has to be, try again. See, this is why you need to write down what you know. It's 14. Thank you. Bam. Our x's are already together in this problem. So you could add 9 and divide by 5 if you want to, but what minus 9 gets you 16? Try again. 25. So what times 5 gets you 25? 5. 6 times a number, that's that, right? Is 8 more than double the number. How do I write double the number? So is this true? No, which one's bigger according to them? Yeah, it's not always the case, right? If n was negative, 6n would actually be smaller than 2n, but it does say this is 8 more than this. So if 6n is bigger, what do we need to do to make it equal? Yep, go ahead, Mars. And you were wrong. Add 8 to 2n, 8 to the smaller one. Add 2n to, what were you saying? That's crazy. All right, bam. We need to get all our variables together, so I'll subtract this over. That becomes 8 after I subtract it over. You totally can, but why would you? This is quicker. N has to be 2. Are you guys seeing that? Subtract 2n to both sides. My goal is to always get my variables in one spot, so it's very easy. Okay, so it's very easy for me to solve the equation in my head. Can I get everything all organized? Absolutely, but if you already see the answer, just go ahead and do it. Like, for instance, could I divide everything by 4 here? Sure. But why not just use your brain? Hey, look, we're on the mediums already. Are the variables all together? No, let's get them all together. 5 equals 18 plus 9r. You guys seeing it? Dominic? 18. We know we need negative, right? 18 minus what gets you 5? So we need this to be negative 13. So we know 9r must equal negative 13. Are you smelling what I'm stepping in? What do you times by 9, Dominic, to get negative 13? Yeah, because the 9s divide out, and I get negative 13. I'm right. Stop using decimals. Speaking of which, stop using decimals. What can I multiply by that'll get rid of all the decimals? 10 will work. They're all tenths. That'll work. When you multiply, you have to do it to every term, and this only works if it's an equation. Is this an equation? Yeah, so it's legal. We get 25y's. Yes, the numbers are bigger, but at least they're not decimals. Minus 360. Are the variables all together? So let's do that. This becomes 9y, and I'm actually going to move the 50. Well, I don't know. I'll move the 50 over by subtracting. Why not? If I subtract 50, I'm down to negative 410. Are you smelling what I'm stepping in? Dominic, what do I times 9 by to get negative 410? 9 over 9. So Dom, the idea is that if I plug this in here, right, these 9s divide out and I get negative 410. Why do they divide out? Because it says divide by 9. That's why the divide by 9 needs to be on the bottom. Oh no, are the variables all in one spot? No. Oh no, there's fractions. What can we do? What number can we times by? That's one way to do it, to get commie denomies. That's totally fine. I'm not going to do that. I'm going to multiply by 8 to everything. You actually did both of those last time, Lexi, and I told you it was unnecessary because you ended up doing this anyway. Yeah, well, it shouldn't make you mad. It should just be like, ooh, I can do it simpler. Bam, 8 times negative t is negative 8t, yes? What is 8 times 3 divided by 4? What's 8 divided by 4? 8 divided by 4 is 2 over 1, and so we get 6 over 1, which is 6. Hey, 8 divided by 8 is 1. And 1 times t is just t, right? What's negative 6 divided by 8? Or sorry, times 8. Times 8. 8 times 5 is 40. So 8 times 6 is 48. Thank you. See how the numbers are bigger? How did I know to multiply by 8? I needed a number that was divisible by 8 and by 4. What's the smallest number that divides by 8 and by 4? 8. 16 could have worked. You answered the opposite question. 16 could have worked, but why multiply by a big number when small number do job? The variables aren't all in the same spot, but now they are. How did I get there? How did I get there? I added 8t, which makes this 0, and now I'm here. Dominic, what minus 48 gets us 6? It's got to be bigger than 48, right? How much bigger than 48? Go ahead. It's 54. Yep, 6 bigger. I know what she's thinking. She's thinking with the 9. 9t must equal 54. 54 minus 48 is 6. Dom, what do you times by 9 to get 54? Yeah, or 54 over 9, right? I'll take either. Honestly, this idea is going to be way more useful in Algebra 2 because most of your answers are going to be nasty. Are all the variables together? No. Do I subtract 13 from negative 20u? No, they're on the same side. So if they're on the same side, you just put them together like it says. I get negative 7u's, right? What do you notice? I have negative 7u minus 9, and I have negative 7u plus 16. Can I ever have something minus 9 equal the same thing minus 16? No solution. I'll prove it to you. If I add 7u to both sides, guess what I get? I get this. Is that ever going to be true? No. Either you done goofed, or it turns out the thing they gave you is impossible to make true. All right, down here, are the variables all together? No. Here's what I get, though, if I combine those two numbers. Check this out. I didn't even combine the variables. Is 9 minus something going to equal 9 minus something else? No, if you take 9 and subtract something, and then you subtract something else, right, they're never going to be equal. So guess what? No solution. Oh, wait, hold on. There is an actual answer to this one. Thank you. Sorry, I was planning on making a mistake, and then I forgot that I was going to make a mistake. There is one number that works. 0. 9 minus nothing equals 9 minus nothing. Here's how you can prevent this mistake. Subtract 9 from both sides. You get negative 22y equals negative 170y. Add your y's together. This becomes 0. You get negative 148. The only number you can times negative 148 by to get 0 is 0. How do we know that 8 is not a good answer for this? 8/3 plus 21 is going to come out to a fraction, right? That's not a problem in itself. Why is that a problem? Why is it a problem that this side comes out to a fraction? Because the other side doesn't. 5 times 8 minus 9 is a whole number. Will a whole number ever equal a fraction? No. Write something. I don't care. My brother is 6 times as old as I am. So here's my brother's age. Here's my age. Is this true? Who's older? The brother. By how much? So that means he's a bunch older, yes? Whoops, sorry. So what do I need to do to make them equal? 6 times your age. 6'7" is what you keep sounding like you're saying. You're saying 6M, aren't you? 12 years from now. Hey, 12 years from now, this is how old your brother is, right? 12 years from now, this is how old you are. Who's older 12 years from now? Well, still your brother, right? That's how this works. But he's not 6 times older now. Now how much is he old? How much older is he? 3 times older. So we need to take the smaller age and times it by 3 to make him equal. Hey, guess what? Elimination substitution. I would use substitution, wouldn't you? Isn't b equal to 6m? So now we have this. You see how I took the bottom equation and I replaced b with 6m? Why is that a good move? Why is replacing b with 6m a good move? Yeah, we're down to one variable now. Yes. After I subtract, I get 3m plus 12 equals 36. Bam, what do you add to 12 to get 36? So what does m got to be? Or 24 over 3, yes. Now, what do they want to know? Yep, so we want b, yes? If m is 8, what is b? 48, yep. No. I hate this. Skip it. Bogatitis has nickels and dimes. There are twice as many dimes as nickels, and she has this much money in her bag. How much many nickels does she have? That's what we want to know. No. Stop. N plus D equals, or sorry, let's do it this way. Is this true? The number of nickels equals the number of dimes. No, what is more? Twice as many dimes. So that means we need to double what? Nickels, and now they're equal. All right, then I see this mistake a lot. Number of dimes, number of nickels adds up to $26.50 in dollars. Is that true? No, that's the number of coins, right? That does not get you the value. How do we turn number of coins into value? Times the value per nickel times the number of nickels. Times the value per dime times the number of dimes. Now we have value plus value equals value. Elimination, substitution? I would do substitution. We get 0.05n plus 0.10 times 2n. Remember, always plug things in parentheses whenever you replace them. I'm replacing D with 2n. Are you seeing it? So now I have 0.05n plus 0.2n equals 26.50. 0.2 is the same thing as 0.20. What can I multiply by to get rid of these decimals here? If I times everything by 100, I get 5n plus 20n equals 26.50. What can I divide by to make this problem easier? N plus 4n equals, if I divide this all by 5, how many times does 5 go into 2,000? Okay, better question. How many times does it go into 1,000? 20 is 100. 200. So that's 400. And it goes into this. It goes into 600 how many times? 5 goes into 600 how many times? 1,200. So we have 1,200. We've got 400. Whoa, hold on. 120 is what I meant. So we have 400 and 120. That's 520. And then we have 5 goes into this 10 times, right? So that's 530. I think I made it way worse. Sorry, I'm tired. What's your question, Haley? Yeah, absolutely. Is it 530? 5 times 5 is 2,500. 5 times 30 is 150. Yeah, I win. Okay, cool. So this is 5n equals 530. 5 times what gets you 500? Yep, 106 gets you 30, so it's 106 nickels. And that's all we want to know, so we're good. White was asked by her teacher to subtract 7 from a certain number and then divide the result by 4. So here's a number. Subtract 7 and divide the result by 14. Instead, he or she, we're switching back and forth here because I forgot to change the things, subtracted 14 and then divided by 7 and got 56. Are you seeing this? Now you are. What would the answer have been if he had worked the problem correctly? What we need to know is what the number was, right? Can't we figure that out from here? Yep. If we times everything by 7, or you think, what do you divide by 7 to get 56, right? Whatever you want to do. N minus 14 equals 7 times 50 is 350. 7 times 6 is 42. So we're up to 392. Dominic, what do you subtract 14 from to get 392? It's got to be bigger than 392. Yep, he's right, 406. Right, 406 minus 4 will get you 2, and then minus 10 will get you 90, right? So n is 406. So that means we have 406 minus 7 divided by 14 to figure out. That's going to be 399 over 14. Does it come out to a nice number? I don't know. Does 7 go into 399? 2 definitely doesn't. So yeah, it definitely isn't going to come out to a nice number. Do you see how we're dividing by 14? That means divide by 7 and by 2. Can I divide this by 2? So how can I divide by 14? Boom, done. Last page. What do we need? How are we going to get them? Yep, you can times by 5 over 5 and x over x to get here, right? X over x puts an x there, 5 over 5 puts a 5 there. Why don't we just times everything by 5x over 5x then? Because we're going to have to times everything by 5. We're going to have to times everything by x. So why not just times everything by 5x over 5x? When we do so, check this out. In the first term, Does the 5 divide out? No. We get 20 in the top. Wait, what am I doing? This is an equation. Ah, Lexi. We don't need times by 1. It's an equation. Why don't we times everything by 5x? All right, fam. 5x times 4 is 20x. What happens when you take 20x and divide it by x? You get 20. 5 times 4, x divided by x goes away. That's why we did it. Over here, what divides out? 5's divide out, so we get negative 6x. Over here, what divides out? So we get 10, positive. Over here, what divides out? 5, so we get 2x. Hey, look, this is like a problem you solved previously. You definitely can, but it's going to be more messy, which is why I recommend you don't. If it's an equation, go ahead and just multiply by a number bigger than 1. It's okay. It's an equation. You can do that. It's still balanced. Yes. 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 You do it when you do elimination and substitution. Don't you? All right, fam, you can either say let x be this crap, or you can just not be afraid. Check this out. If I add this over, I now have this. 2 of them, yes? Yes, right? Add that over, now I have 2 root 3 r's. Okay, Dominic, my r's are all in one term. What minus 13 gets you 5? Try again. He didn't finish his answer. 18. So what do we know? 2 root 3r must be 18. Very good. I need to move this mic over. I'm sorry, people watching at home. Maybe it was really quiet. All right, so fam, what times 2 gets you 18 then? So what do we know? Root of 3r is 9. Stop. The root of 3r must be 9, right? 2 times 9 is 18, so this part must be 9. What do you root to get 9? So what do we know? No. What did I cover up? That part must be 81. What do you times by 3 to get 81? Or 81 over 3, yep. Three's done. Are you ready for 4? Hey, look, it's the same thing as 2, except now we're plugging in 2 variables. This is where everybody just tries to do the math in their head. Stop doing that. We have x minus 2 times whatever y is. What is x? It's 5. Good job. What is y? So you write it out like this. This means times, right? So this is 5. Negative 2 times negative 2 is positive 4. Answer is 9. We have 3 times whatever x is times whatever y is. Write it in parentheses for the love of God. What is x? What is y? Is this going to come out negative or positive when we multiply it? Negative what? 15 times 2 is 30. Some of you guys like to distribute the 3 here. I don't know what is wrong with you. Stop doing that. You only distribute across multiple terms. There are not multiple terms here. It's all one term. All one term. Next one. This says we're going to do 2 times whatever x is times whatever y is squared. Then we're going to add whatever x is times squared times whatever y is. What is x? 5. I swear to God, use colors on this. You guys look at your old quizzes and write the wrong numbers in all the time. Negative 2 is what y is. So wherever you see a y, replace it with parentheses negative 2. Wherever you have an x, replace it with parentheses 5. Okay, so now, what does it mean to square something? If you write out or think about it in your head first, you will answer the question of, do I square first or not? And the answer is yes, because squaring means times it by itself. If you did 5 times negative 2 and then squared it, what is 5 times negative 2? What is 5 times negative 2? And negative 10 squared means negative 10 times negative 10. Do you see negative 10 times negative 10 here? No. So you have to square first. It's not a rule that someone made up. It's just literally do what it means, and you'll figure this out. Is this going to come out negative or positive? Positive. This will come out positive 4, positive 20, positive 40. Is this going to come out negative or positive? Oh, on God? Sorry. This is going to come out negative, yeah? Because it's going to be 5 times 5 times 2, make it negative. That's negative 50. So either think of it as adding negative 50 or subtracting 50. I don't care. The answer is negative 10. How we feeling? Dece or no? If you write out what it means, you won't make mistakes. If you're struggling with negatives still, you need to meet with me next semester so we can fix that. That's the one mistake everybody has, even still in Algebra 2, that holds them back. If you learn how to deal with negatives, you'll be fine. Which is why we need to stop focusing on random crap in middle school, like dividing by decimals and like ridiculous long division, and instead focus on getting you guys to actually understand negatives. Because apparently dividing by negatives and division and all that crap you guys get pretty easily because you just do the algorithm, but you don't understand negatives, which is bad. All right, fam, what are we doing here? Thank you. What is 4b plus 2b? Good. What is negative 7a? Yes, you do need to pay attention to the signs. Plus 3a. Negative 4a. Dom, what are we doing here? Thank you. So we have 9z, and we're going to add it with like terms. Do you see how I have negative 9z here? 9z plus negative 9z is 0z. What is 0 times z? 0, so don't even write it. If you write z here, thinking that the 9's go away, I will mark it wrong, because 1z is not the same thing as 0z. All right, now I've got negative 2y, and I'm adding it to positive 2y. That's also 0y's. Sometimes it do be like that. 6x's plus 3x's is 9x's, so there you go. Will it always go away like that? No. Hey, look, we're timesing everything. So we're timesing x by itself twice, and then we're going to multiply that by y times itself twice. And then we're going to times it all by z 4 times. So that's easy. Write it with the dots in between or don't. I don't care. Over here, how many times are we multiplying a together? And then we're going to times that by b. How many times? 7 times. Numbers are hard. It's okay. No one cares. Calculation. Hey, let me be very clear about this. Calculation is to math like spelling is to English. As long as they can tell what you're trying to talk about, you're good to go. In fact, it's not even spelling. It's like something even worse. Calculation is this much of math. If you're good at calculation, are you good at math? No, you're good at like this much of math. If you're bad at calculation, are you bad at math? No, you're bad at this much. Calculation is silly. That's what calculators are for. We don't learn calculation in here. We learn how to do math. All right. Down here, we're timesing, expand. 35r minus 20s. Are we smelling what I'm stepping in? Here is 3x times x, 3x. 3x squared. 3x times y. Positive. And this is negative 6xz. Are you smelling what I'm stepping in? Dominic? What are we doing here? Thank you. I've got x, and I'm taking away 5x's. Thank you. I've got, oh, good, this one has a y in it. Okay, awesome. Some of the times I forget the y here, and then you don't subtract these. Actually, I want to show you guys that. 7y minus negative 4y. Fam, if we're minusing a negative 4, isn't that the same thing as adding? So we get 11 y's. Another way to do this is x plus 7y, distribute the negative, negative 5x, distribute the negative, positive 4y. Easier to work with, isn't it? 11, negative 4. Factor. Ooh, I can divide them all by 6, so I get negative x plus 4y, right? Factoring doesn't change the problem. Is this an equation? So you can't divide everything by 6. That would change it, right? Think about it. If I have 3 plus 6, what does that represent? 9. If I divide everything by 3, does it still represent 9? No. If I have an equation, though, even though it doesn't represent 9 anymore, is it still true? So you can totally divide everything in an equation, but you cannot divide everything or times everything or add random stuff that isn't 1 if it's an expression. This is an expression. So we factor. How many copies? 4 copies. What do we need here? If I times by x over x, aren't I going to get this? If I times by y over y, aren't I going to get this? Times by x over x. What is x over x? What is x over x? 1. Timesing by 1 doesn't change anything. Do you see how this is an expression? That's why I have to times by x over x. I can't just multiply to get rid of fractions because it's not an equation. Down here, what does it mean to get x in terms of y? Or sorry, let me say it again. Dominic, what does it mean to get x in terms of a, b, and c? It's because when you have speakers and they want to make them high quality, they don't shield the wires so that the sound is more pure. But the problem with not shielding it is whenever I get a text or something, the radio signals that are going through interfere with it, right? Okay, cool. So we want to get x in terms of the other variables, right? Dominic, give me one thing I can do to get x more on its own. Yeah, how would I get rid of the divides by a? Times everything by a, right? What's another thing I'm going to have to do to get x on its own? Add b. Add b. If you subtract b from negative b, you get negative 2b. It doesn't go away. I'm going to add first. I usually like adding and subtracting first. That's just kind of what I do. You only have to do it to both sides. It doesn't have to be to every term. So do not write this and then do your next thing. For the love of God, stop doing this and then do the next thing. Write down what happens. This becomes x over a. What is negative b plus b? Good, which is why we did it. And when we get c plus b. All right, cool. Now we're here. Dominic said we should times everything by a. Let's do that. You can either times them individually by a and get ac plus ab, or you can write a times the quantity of c plus b. I don't care. Either way. Doesn't this mean times everything by a? Is x on its own? Who cares? All right, Dominic. Lexi's not going to help you this time. Nobody is. What does b in terms of a, c, and x mean? Take a guess. What does it mean to get b in terms of a, c, and x? Here we got x in terms of a, b, and c. Yeah, we need b equal to a bunch of junk with x, a, and c in it, right? So this is our goal. So Dominic, give me one thing I can do to get b more on its own. Yeah, I would subtract that. Whenever you want to get rid of something completely to make it 0, you either add or subtract. In this case, it's positive, so I'd subtract, right? I like that strategy. Let's do that. So I'm going to subtract x over a from here and here. I must be getting emails. I'm not getting texts. These subtract to 0, which means I get negative b equals c minus x over a. Now, am I done? What's my goal? This is negative b in terms of a, x, and c. I want positive b. Dom, what can I do? Robeson. Yeah, times everything by negative 1's legal, right? You could also add b over and move everything else the other way. I don't really care. I think timesing by negative 1 is cool, so we'll do that. So what we get is b equals negative c plus x over a. Pop quiz. Is this the same answer? It is. C's negative, x over a is positive. Either way works. Are we feeling better? That's not my problem. You can stay for the next session if you want. We can start with 5 for them. They want to get to 5, right? So why don't we just start with 5? I would do that if I were you. All right, fam, do we want to see any of these? I want to see you plug stuff in. Does this come out to negative 2 or positive 4 or negative 4? Positive 4. If you don't put the parentheses there, it would actually come out to negative 4 on a calculator. You need to plug stuff in. This is a half. Says evaluate, so you need to simplify. This has negative 2 to the 5th. Is it going to come out positive or negative? Negative 32. This down here is 3 times whatever y is minus whatever x is times 3 times whatever y is plus whatever x is. X in this case is 5. Y in this case is negative 2. This is negative 6. What is negative 6 minus 5? Negative 6 minus 5. Negative 11. What is negative 6 plus 5? 11. Plug these in down here. I have to go over these because you guys refuse to like plug stuff in. A times C. Are you with me on that? A times B plus B times C. These are not like terms. Fam, what is 2/3 of 9? 9 divided by 3 is 6, or 3 times 2 is 6. What is negative 2/3 times negative, or sorry, what is 2/3 times negative 1? Negative 1 times 9. We need commie denomies. This is 18/3. Are you seeing it? Times by 6 over 6? Or sorry, 3 over 3? I think you mean 3 over 3 here as well. This will get you 27 over 3. Isn't 27 divided by 3 9? 18 divided by 3 is 6. I didn't change it. So I get negative 29/3, and I got positive 18, so it's going to be negative 11/3. A is 2/3. B is negative 1, and we're squaring it. What is negative 1 squared? 1, so that's 1. We can ignore it. What's 9 divided by 3? Times 2? 9 divided by 3 is 3. Then you divide by 2. You could have done 18 divided by 3. That works too. 6. All right, now I'm going to ask you if you want to see them or not. Yes or no? Speak now or forever hold your peace. Yes? Which ones do you want to see, Haley? You want to see this one? All right, what do we need? These don't. That's 9c squared, right? If we times by 3 over 3, because this is not an equation, we have to multiply to get common denominators. So we have 1d squared over 3. And then this is going to be negative 12d squareds over 3. Are you smelling what I'm stepping in? How many d squareds will I have if I subtract 12 of them from one of them? Negative 11d squareds over 3. And this is positive 9c squared. So altogether, we get this. Yes, yes, yes? Okay. Here we need common denominators. This one's really simple. What can we multiply by to get all the same denominator? Over 3, because that won't change anything. We're going to get 6a plus 3a plus 5 plus 3a minus 8 all over 3c. Then you put them all together. That's going to be 12a minus 3 over 3c. It does say simplify. Fam, what do you notice? We have a factor of 3 in the top. This is 3 times 4a minus 1 all over 3. 3's divide out. Boom. Any others on this page? I said I wasn't going to hold your hands, and then I held your hands for like last 2 quizzes. Sorry. Okay. What is nice is that if this is going too quickly for you, through the power of YouTube, you can pause. On YouTube, I will send a link to everybody in Algebra I after I upload it. Not until everybody agrees. Anybody want to see any of these? Are we sure? Fun fact about this one, and then I'll move on. See how these are the same? Oh, wait, they're not the same. That one's a plus, that one's a minus. Yeah, it sucks. Yeah, anyway. I was going to say, if they were the same, you got 3 of them minus 5 of them, you get negative 2 of them. But they're not the same, so you do have to distribute. That sucks. All right. Let's talk about these real quick. Commie denomies. How do I get common denominators here? Try again. If I times by 2x over 2x, I get 10x squared on the bottom, right? So I got 3y minus 14x plus 2xy all over 10x squared. Question, why is this positive? Right here, this term right here. Got him. It is. It is positive. This says minus all of this, yes? So that means minus 7. When we times it by 2x, we get not minus 14x, yes? This says minus negative y. Positive 2xy. Gets them every time. Dominator. What does it mean to get a in terms of the other variables? Good, this is our goal. Give me one thing I can do to get a more on its own. So, why is this one harder? This one has a diamond next to it. Why is this harder than getting b or c or x on its own? It's in the denominator, so let's get it out of the denominator, okay, by timesing everything by a. This is a weird move because you're not going to, like, get fewer a's here, right? You're actually going to have a's in more spots, but it gets us to a spot where we know how to solve it, at least somewhat. So now let's get everything with a on one side. That's going to get me here by adding a, b to both sides, yes? Now here's the catch. I can never get a in one spot unless I know this technique. It's more than adding, multiplying, dividing, or subtracting. You have to actually understand algebra. That's why this one's hard. What do I do? What did she do? What is it called? Factoring, opposite distributing, right? So now that we have that, we have a times something. How do I get rid of times something here? Divide, so I get x over c plus b equals a. It's the only way to do it. You have to be able to factor. That's why you want to get all your variables on one side. The ones you care about anyway. In this case, it was a. All right, that's it. 5. I'll just start with 5 for the next class. Nobody asked me to do that. So, here we are. X in terms of y. Dom, what does x in terms of y mean? How do I get x on its own here? Add 4y, because that makes a 0, yes? Bozo, bozo, bozo. Adding 4y makes a 0, so you got to add 4y to both sides. Do what makes sense. A lot of you guys write stuff, and it's like, that doesn't make sense at all. Did you think? No, you just followed random crap. Now what do we have to do to get x instead of 3x? All right, I don't care whether 7 is divisible by 3 or 4 is divisible by 3. If they both are, cool, but, like, they're not, so just write divide by 3. Ta-da! X in terms of the other variable. This is super important. Y in terms of x. The opposite. So we're going to subtract 3x and get this. Isn't subtracting 3x going to make that 0? And divide by negative 4. I want to talk about this real quick. If you write this, this is fine. Some of you guys are like, wait a minute. I can divide everything by a negative. 7 divided by negative 1 is negative 7. This divided by negative 1 is positive 3x. And now I only have a 4 on the bottom. Sometimes that's preferable. These are both the same answer. Dividing everything by negative 1 does that, right? All right, give me numbers for Q and P that make this work. Add a line. 1 and 1. 3 minus 2 is 1. Give me another pair of numbers. That won't work. Unless you're going to use a fraction. Are you going to use a fraction? Yeah, that'd be 12. We need this to be 11. So, fam, I want to point out that one of her answers is right, but it's kind of gross. Do you see how if this is 12, we need this to be 11? 12 minus 11 is 1. Are you with me on that? 12 minus 11 is 1. How do I make this 12? 4. How do I make this 11, Dom? 11 halves. Okay? 0 minus 0 is not 1. So this is a fine answer, but it's going to be fractional. I want to find some nice numbers just so I can show you something neat. In fact, here's what I'll show you. This is delta P right here. And this is kind of delta Q. We talked about this previously. Delta Q is what you change in the Q direction. Delta P is what you change in the P direction. No one remembers this because we did it right over break. So delta P is plus 3. And I said this is kind of delta Q. It's actually plus 2. And so you can use that to your advantage. Apparently 3 and 4 gets us a nice number. 9 minus 8, right? And we can keep doing that. 5 and 7. Always check them after you do it because a lot of you guys goof this up. But yes, in standard form you get that. Here's why. What we're saying is that what do I add to Q and what do I add to P so that I still, after increasing them, I still get 1, right? Well, if you think about it, that means 3Q plus 3 delta Q minus 2P minus 2 delta P equals 1. And we know we want to get back to the original problem. So this and this have to cancel out, as you say. Right? They have to equal 0. So do you see how if Q is 2, delta Q is 2, and delta P is 3, we get 6 and negative 6. Are you guys seeing that? 6 and negative 6 go away. So that means delta Q must be 3 or 2, and delta P must be 3. That's the logic. Shorthand's just you need opposites here. Okay. I need 5 points. Find ordered pairs that work. Use elimination or substitution. I don't care. I'm skipping it. Anybody want to see these? Page 2. Anybody want to see these? How to substitute, how to plug things in. Okay, it's easy if you know it. If you don't know it, it's impossible. I'm going to do one of them. Substitution is what we have to do. X is this. Do you see how I got there? I minus 2y. I'm going to take all that stuff and plug it in here. Highly recommend you come back the next night. Page 2. You'll start it and you can come back tomorrow, yeah? This is 11y's positive, and this is negative 40. Isn't this going to be 77? So we know 11y equals 77. What does y have to equal? If y is 7, 10 minus 14 is x. X is negative 4. That's called substitution. This thing right here that we did is called substitution. We switched out a variable for another one, which gets us one variable, and then we win. Anything on this page? Y in terms of x. Dom, what does it mean to get y in terms of x? With x in it, right? Not just y by itself. Is this y in terms of x? No, it's y on its own, though. It's y in terms of what? T. So here's what we're going to do. I know x equals 6 minus t, which means t equals 6 minus x. Do you see if I add the t over and subtract the x over? It's kind of trippy because they're like the same thing, just switching the variables. Whoops. Sometimes it happens that way. If you know t is the same thing as 6 minus x, subtract the x over, add the t over, right? Can't you just plug that in here? Hey, look. Dom, is this y in terms of x? It is. You guys are like, but I want to distribute. I mean, go ahead if you want to, but it's y in terms of x, isn't it? Cool. You did it. Solve using elimination or substitution. I'm going to show you elimination on this one. If you add them, we get 5x's equals 20, don't we? Which means x is 4. Pretty slick, huh? This worked because we have negative 7y and positive 7y. If you don't have something like that, you're not eliminating anything because it doesn't go away. See how y's went away? That's elimination. If you add them up and nothing goes away, that's not elimination. Is it legal? Yeah, sure. But it didn't actually get you down to one variable, so it's not super helpful. Although sometimes it can be, right? Tweedledee, tweedledum. So we know x is 4. That means this is 8, right? Yes? So we have 8 plus 7y equals 6. Dom, what do I add to 8 to get 6? So what do we know? Dom, what do you times by 7 to get negative 2? Well, 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 if it isn't the thief. How do you feel? There are your two answers. This works. If you try it in the other equation, don't we get 12 plus 2? 12 plus 2 is 14. All right, I'm going to help these guys get their quizzes. We're starting with quiz 5 for you guys because these guys want to continue quiz 5. Right? Is anybody sticking around for quiz 5 stuff? You're going to stick around? Okay, cool. So here's what we'll do. I will end this for tonight here. Okay, so everybody listen up. So I'm going to end this video now, and I'm going to start uploading it to YouTube. I will send you all the link for this video, and then I'll start a new one after I print out stuff for these guys, and we will start with Quiz 5 in video 2. Okay? Quiz 5 will be the beginning of video 2. Okay? All right, bye. Love you all. Good job. I highly recommend you show up twice.